Am I audible to all of you?
Yes, sir.
Yes, sir.
Okay. 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 So we are just going to start the session. Uh, Professor Pankaj Khanna, am I audible to you?
Yes, is my voice coming to you?
Yeah. Yeah. Sir.
Yeah, thank you.
Okay. Okay. Thank you, sir. Uh, Yes, we are going to start, sir. So, okay. Well, good afternoon, ladies and gentlemen, honored guests, team colleagues, dear scholars, and fellow participants. Welcome to this session of International Conference on Integrative Chemical Science for Health and Environment 2023. In this session, we are going to hear 14 participants and we will explore the intriguing world of chemical science for health and the environment. It is my privilege to introduce the Professor Pankaj Khanna, who will be guiding us through today's session as our chairperson. Professor Pankaj Khanna is from the Department of Chemistry, ANDC College, University of Delhi. He obtained his PhD and master degree from the University of Delhi. He has teaching and research experience of about 20 years with more than 34 research articles in various international and national peer-reviewed journals, and also bears 4 patents to his profile. Professor Pankaj Khanna has a specialization in synthetic, organic, and natural product chemistry, and his research interests encompass a diverse range of topics, such as synthesis of novel heterocyclic systems of medicinal interest and drug discovery, in silico studies including molecular docking and ADME analysis, isolation and structure elucidation of natural compounds, interdisciplinary research for chemistry education, and flipped classroom and blended learning. He has been awarded many research projects from the University of Delhi and under DST sponsored scheme and also the co-mentor of many elite projects. He has been recognized as a PhD supervisor by the Department of Chemistry, University of Delhi. He is the recipient of many prestigious awards, such as Digital Literacy Champion by Campus of Open Learning, University of Delhi, Vice Chancellor Fellowship, University of Delhi, Best Poster Award and Certificate of Appreciation for Research Display at the DU Convocation 2016 for the work done in Innovation Project ANDC 305, designing a virtual chemistry lab for undergraduate students. Professor Khanna is actively involved in many administrative assignments, such as he is a member of committee for the revision of various syllabus or various courses. He has been member of organizing committee of more than 10 workshops, seminars, conferences, symposiums, and Professor Khanna has acted as a jury member for the assessment of prestigious Inspired Scholarship organized by DST New Delhi. He has been also resource person in more than 15 workshops. He is actively involved in college committees such as IPAC member 2021 Purgent, convener of admission committee 2022 to 2024, superintendent and deputy superintendent of SOL examination committee, convener of Avikiria, that is the Chemistry Society 2018 to 2020. Besides this, he is a member of many professional bodies like reviewer of Frontiers in Chemistry, reviewer of Chemistry and Biodiversity, reviewer of Chemistry Selected Willy Journal, member of Indian Society of Analytical Scientists. So I have no doubt that today's session will be an informative and productive gathering. So please join me in giving a warm welcome to our chairperson as well as our speakers. So without further ado, I invite Professor Pankaj Khanna to begin the proceedings. Thank you, sir, for being with us. And in last, I want to request that please try to complete your presentation within 10 minutes so that we can give the sufficient times to all participants. Thank you. Over to you, sir, Professor Pankaj Kari.
Thank you, Dr. Chand. Thank you for your. Am I audible right now?
Yeah, yes, sir, you are
Yeah.
audible.
So thank you for your an elaborate introduction. I apologize that I could not provide you with a limited words, and you took it from my
Okay,
website, I suppose, and
okay,
you gave a
okay,
very elaborate. And thank you very much for that.
okay,
And
welcome, sir, welcome.
the work might sound like big things, but for the research scholars, I would like to suggest that whatever work you do, whatever things you are into, you should be focused for whatever you are doing, and you should not look back. I never look back on my what I have done. I have to see what I can
Hmm.
do in future. So
Yeah,
I again thank you, Dr. Chand, for the introduction. And may I
thank
know
you,
the
sir.
time limit is 10 minutes. So would there be any buzzer kind of thing you have like
No,
put up
no,
on
no,
8?
no, no, sir. There is not any budget kind of things. You
So
will have to remember that every participant get sufficient time. So that say they complete within 10 minutes, so they can present their works within 7 minutes to 8 minutes, and 2 or 3 minutes for questions.
2 minutes for questions.
Yeah, 2 or 3 minutes for
No,
questions.
is I'm just asking Dr. Chand that is anybody taking care of uh, whatever we are talking that in 8 minutes there will be some like a ring kind
No,
of thing. How would the scholars would know that the time has like gone
no,
beyond?
no, sir. So there is not any foundation, but we have just keep in mind that
Okay.
there will be time.
Okay, so I will take care of that.
Okay.
How much possible, me and you can take care of that. That if it goes beyond a particular time limit, then we'll
Okay.
just say that you wind up in 1 minute because we have to
Okay.
keep a check now. Otherwise, they might go
Yeah.
on and on. So we should
Okay.
interrupt in between, right?
Oh, okay. Okay.
ठीक है तो ये ऐसे करते हैं the order will be the same as you have given in the sheet to me.
Yes, sir. Yes.
So
And one participant has been added in last moment.
right, you
Doctor.
told 14, right?
Yeah,
No problem,
Doctor. Okay.
no problems.
Okay.
So we can start, and all the best to everyone. Please don't take it like a competition. I would suggest that because we all are scientists here and we are presenting scientific works. So, and nobody is going to get a Nobel Prize for this. So we should limit things crisp and clear, minimizing the introduction part and giving your own work if it is possible. Because if it is your own work, research article kind of, if it is a review article, then you can just give the key points of that and limit the time as Chansar has already told us. So all the best to everyone, and we can start with the first one.
Who is the first one? Um, I think she is Poonam Singh Vati. Poonam Singh Vati. Sir, I think Poonam Singh Vati is not in this session.
Yeah,
So
we can
can
move on to
we?
the next one when she joins
Yeah,
because there are
yeah,
only 15 participants in the room.
Already.
So you and me make two, and she might not
yes.
have joined, or she might be getting joining or having some problems. So the next one is uh,
Uh,
Miss
The
Samriti
Poonam
with.
Singh is Bhatti is there, but he is unable to connect to the system. Yes, yes, sir.
Okay, so
Yes,
we
sir.
can take the presentation in the latter part of the like. We can start
Yeah.
with the second one, Dr. Chan.
Yes, yes,
Yes,
sir,
sir.
of course, sir.
Yes, sir.
So we can start with Smriti Ved.
तो इस पर एग्जिट करो
Yes.
शेयर स्क्रीन को.
Good afternoon, sir. Yes.
Good afternoon, ji. Good afternoon.
Yes.
You can start, Smriti.
इसमें करो. Yes.
So is my screen visible to everybody?
Yes, yes. Very much, very much.
Okay. Good afternoon, everybody. Do I need to on the video also? Good afternoon, everybody. I'm Samriti Vaid from Hello. So may I start the presentation? Hello.
Ma'am, you already shared your screen. Better to start with the presentation.
Yes, sir. Sir, hello. Am I audible to everybody?
You're very much audible, ma'am. You just
Ji, sir. Sir,
Yeah,
then
you
I'm
can
going
start,
to...
Samriti. Yes, you have gone mute. You are now mute. Just unmute yourself. I think you have been mute.
Yes.
Yeah, it's okay.
Oh, sorry. Yes, I am Samriti Vaid, working as research scholar in Department of Chemistry in Guru Nanak Dev University under the supervision of Dr. Varinder Kaur. Today I am here to present my work entitled as Adsorption of Reactive Glue 235 on Surfactant Modified Jute Fibers, Equilibrium Kinetic and Thermodynamic Studies. Yes. So first of all, the thing come to our brain before starting any work, that why do we need to do the research on this. So actually the reactive dyes, everybody, you might be knowing only that the dyes in the textile industries, when the clothes are dyed, the apparels are dyed, then definitely the dye which is coming from the effluent, that is a very big problem for the society. Yes, because that has to be removed from the water, otherwise it's going to be a huge problem regarding basically for the animals present there in the water, amphibians life. Yes, and so on. Yes, see, you can see this picture coming from the water coming from the textile industry, and see how horrible it's looking, its color, and these all are going to be a big problem for the society, the drainage, this all. So definitely we should think, we should keep on thinking new things, new adsorbent and new methods by which we can remove the effluent and remove the color from water. And in this there is a small work thing, what we have done some contribution towards this. We have tried to you can see these are why this study is important. Yes, this is a very hot topic. See, there every day we come to see there are these public papers in newspaper also, there are the reports they're coming that the effluents coming from dye industries are spoiling groundwater in different areas. Yes, so for that we have decided to do the work on this. So in this we are using reactive dye. So why we are using reactive dye only? Dyes are so many. There are different dyes, direct dye, acid dye. But why we selected reactive dye? So because generally reactive dyes are the maximum used in the textile industries. Yes, but the problem is that although it has very good affinity with the text with the fiber, with the apparel, but in the negative effect, the negative part is, although it has very good affinity, fastness is very good, color fastness is very good, but a large amount of dye come to the effluent. Yes, तो जहां पे एक तरफ वो बहुत अच्छा एब्जॉर्प्शन कर रहा है, it's giving good color to the cloth, the next form it's creating a very big problem. So definitely reactive dye के लिए हमें we decided कि let us do something, we design some adsorbent for the reactive dye. Yes, numerous researchers have been already done for removing the color, removing the reactive dye from the effluent. So there are very techniques. So out of them, adsorption is one of those. Yes, in reactive dye adsorption, reactive dye के ऊपर बहुत सारे हुए भी हैं, no doubt. बहुत सारे adsorbent use किए हैं, बहुत सारे surfactant, various surfactants, modified adsorbent has also been used. And surfactant में भी different surfactant, cationic, anionic, non-anionic surfactant use किए, but there are very few researchers रिपोर्टेड जहां पे हमने फाइबर को यूज किया एज अ एड्सॉर्बेंट. यस, तो हमारे केस में हमने क्या किया कि हमने जूट फाइबर को यूज किया एज एन एड्सॉर्बेंट. यस, तो व्हाट वाज हमारा ऑब्जेक्टिव क्या था? टू डिजाइन ए लो कॉस्ट नेचुरल एड्सॉर्बेंट यूजिंग रिएक्टिव डाई. यस, तो उसके लिए हमने जूट फाइबर यूज किया. उसके बाद हमने प्रैक्टिकलिबिलिटी फाइंड की जूट फाइबर की. उसके बाद हमने उसमें उसको कैरेक्टराइज किया एड्सॉर्बेंट को, उसका परसेंटेज रिमूवल निकाला, उसके सारी आइसोथर्मल, काइनेटिक और थर्मोडायनामिक स्टडी की और फाइंड किया कि क्या हमारा प्रोसेस स्पॉन्टेनियस है या नहीं है. यस, so for this let's say discuss we prepared the dye solution. We use 40 mg per liter dye solution. Yes, my dye was Novacron Blue FNR. This is the calibration curve of reactive blue 235. Yes, to find out the concentration, because of the calculation which I did in that, we used the concentration. So first of all, I made the various concentration dye solution, and I reported the I found out the absorbance of that dye solution, and then I made a graph of absorbance versus concentration, by the help of which I was able to find out the concentration of any of the solution of the result which I got. I got the result in absorbance form, and then I got converted it into concentration form. See, this is the FTIR. As I said, the characterization. In the characterization, there are many techniques I used. I use FTIR. I use the TGA. Then yes, although I use SEM, but here I have not given the SEM. The FTIR of the JBT, JCT, and JST. Sorry, I did not have not given the full form of JBT. So I would like to say as such, JBT is the jute fiber which was used before treatment. Then after I treated it with caustic. Then after surfactant treated. Yes. So you can see there is a difference between in these three FTIR. In the JBT, there is a band at very good band at 2925, which is little bit the sharpness of the band is decreasing as we move from JBT to JCT. Yes, and the peak at 1744 is totally it's getting removed. 1644 is also getting removed, and these are the some major peaks which are getting removed when we are converting JBT to JCT. As you can see, what we are doing is we are removing the lignin from the jute fiber. As you can see, I have already said, it contains, jute fiber contains cellulose 70 to 74%, hemicellulose 12 to 14%, and lignin 10 to 12%. And this is firstly, this lignin get removed when we treat it from the caustic. Yes, and somewhat hemicellulose is also removed. Now this is the TGA. When we compare the TGA of JBT, JCT, and JST, we can see there is a difference in the TGA also. Yes, this also shows that yes, there is definitely the difference. There is coming the change in the material content present in the JBT, JCT, and JST. As we are treating, firstly we are treating JBT with sodium hydroxide, and we are getting JCT. So you can see this black one is of JBT, and this is JCT. So definitely there is becoming some loss. Yes, तो घट रहा है, वो पहले ही उसमें convert हो रहा है ना. Then after this coming this JST. Now these are some of the graphs showing the firstly this is the effect of JBT on the effect of the JBT, JCT and JCT dose on the percentage dye removal. As seen from the graph, you can see GST में सबसे ज्यादा percentage dye removal हो रहा है, yes, और JBT में सबसे कम. तो JBT से ज्यादा JCT में हो रहा है. Mean to say, when we are treating it with caustic, the percentage dye removal is increasing, its absorption capacity is increasing, and then after it's further increasing when it's converting, when we are treating it with surfactant. Yes. When we studied the effect of pH, then we did not find any significant change in the percentage dye removal by changing the pH. Mean to say, the adsorbent was not very much it was not very much depending upon the adsorption capacity or of the adsorbent was not very much depending upon the pH. pH का बहुत ज्यादा रोल नहीं दिखा हमें. The next is the effect of contact time. Yes, sorry. In this, the effect of contact time, you can see कि जैसे हमारा on reactive at various initial dye concentration, जैसे जैसे हम dye का concentration बढ़ा रहे हैं, हमने 5 concentration की dye ली, 20 mg per liter, 40 mg per liter, 60, 80 and 100. तो हमने देखा कि जैसे जैसे हमने concentration बढ़ाई तो हमारी amount of dye removed बढ़ रही है with time. Then after we did the main motive was kinetic, isothermal and thermodynamic study. So in kinetic study, we try to study all the reaction kinetic. We try to put all the reaction kinetic for first order kinetic, second order kinetic, then intra particle diffusion model also, and we try to see the which model fits the best. So by the study we came to find out the pseudo first order, everybody might be knowing only, yes, the linear form pseudo first order kinetic model is expressed as this equation, and we put this equation to fit it when we plotted log QE minus QT value with respect to time, which we obtained by the experiment. Then we came to find out we got this plot, and when by using pseudo second order reaction kinetic we got this plot, and when we compared the two, then so you can see in the table layer control, मतलब यहाँ पे boundary layer control ज्यादा अच्छा नहीं है इसमें, and it further showed that just intraparticle diffusion was not the rate limiting step, rather than there might be some other process also controlling the rate of adsorption. It is indicated from the C values that boundary layer effects increases with increasing temperature. जैसे हम देख रहे हैं कि C की वैल्यू बढ़ रही है with respect to temperature, तो इसका मतलब कि boundary layer control effect जो है वो हमारा temperature के साथ बढ़ रहा है. Yes, and next is adsorption isotherm. We also fitted adsorption isotherm, Langmuir isotherm, Friendlich isotherm, yes, Temkin and Dubnin which isotherm. And in the Langmuir isotherm, we came to we got this plot. Friendlich, we got this plot, and from the plot, what we came to find out that the KL value is increasing in case of Langmuir. As the KL is increasing, it signifies that.
Ma'am, we have limited time, so please
Yes, sir.
Can you conclude now?
Yes, sir. From the result, we
Hello?
Sir, I think she has some connectivity issue, sir.
Yeah, sir, there is some. चल रहा है यार, तो कर रहा बंदा नहीं. Now I think.
Yes, sir. Sir, Poonam Singh, sir, here.
Yeah.
Yes, sir, Poonam Singh, sir.
Yes, please.
Yes, sir. इसके सेम में नहीं आ सकता और जाना नहीं.
Professor Khanna.
Yes, sir.
Dr. Chan, who is the next one?
Yes, sir. Yes, sir.
I think Poonam Singh Bhatti is present now, so we can call him.
Yes, sir. Yes, something कुछ error, sir. Please.
Yeah, Poonam Singh Bhatti.
Yes, sir. Yes, sir.
I think there is some issue with you. So can we hear our next speaker? Ishwar Singh.
Hello. This is Ishwar Singh. Hello. Are you hear my voice, sir?
You are very much audible.
Just 1 second, sir.
I request you to please be precise so that we would finish in time.
Okay, sir. You, hello, are you hear my voice, sir? Hello.
Yeah, you are very much audible.
Okay, thank you very much, sir. Myself, Ishwar Singh. I am a PhD scholar from Jaina Vyas University, Jodhpur. I doing my PhD under my professor, Mr. A.V. Singh ji, and my topic of research is application of removal of heavy metals and its application by the preparation of resins. Let's start this presentation. First of all, I made this presentation with the topic for this conference, polymerization-based synthesis and its empirical properties of new natural polysaccharide that is based on combination of propanoic 2-aminopropanoic acid and with a base polysaccharide tamarind. This resin is very much useful for the removal of heavy metal ions like nickel, cadmium, nickel, cobalt, copper, ferrous, zinc. That has been removed by the synthesis. I have synthesized the tamarind. I have synthesized the tamarind DL aniline or tamarind 2-aminopropanoic acid resin, that is TAPA, TAPA, TAPA. This resin shows a great economical for the removal of the heavy metals, as well as environmentally effectiveness due to its natural existence and the hydrophobic type. Some of the chemical techniques, like I did some of the chemical techniques like TCA, FTIR, and SM, pH, and for the removal of the heavy metals from the wastewater or industrial effluents to check the effectiveness of this resin. And it found it's a great extent with regard to the toxic metal ions removal from the hazardous and carcinogenic effluents. And the maximum absorption of this resin, TAPA resin, is occur for the metal, copper metal, that is found approximately 80%. This has to be calculated by its KD values determination. And some of the extent, the metal like zinc is also removed from the heavy metal to a greater extent, up to the 80%. So it is a very economical and removal of a greater extent to remove the heavy metals from the industrial waste or effluents. Then these all the process I have synthesized in my laboratory, and all are the natural process, natural polysaccharides and resin. I have made it natural and very economically. That actually, the natural activities include the weathering of metals like volcanic eruptions and forest fires, natural occurring weathering process. As a result of these sections, metal enter into the various ecosystems and finally enter into the wastewater, and it is destroyed our environment. So it is very necessary to remove it from the wastewater to disrupt our environment furtherly. So heavy metal can exist in a variety of states, including sulfides. Most of states are in the sulfide forms and oxide forms, and some few are in the silicates form also. The wet and dry deposition of atmospheric year after year and atmospheric salts, contact between the water and the rock, and the water oil and other natural causes of the heavy metal pollution of the water. As a response of rising petroleum product, and also there is the existence of heavy metal in the environment. So all these environmental heavy metal can destroy our environment. So it is very necessary to remove it from our environment, and for the removal, this process, the resin removed by the polysaccharide made resin is very effective, and especially for the metal industries where the most of the heavy metals are present. The objective of this work was to synthesize and the objective of this work is to synthesize and characterize the resin-based tamarind tapa to remove the heavy metal ions can be extracted from contaminated aqueous solution or industrial wastewater, either from steel industry, either from metal industry or gorgum industry, or ferrous industries, iron industries. Tapa resin is now how I start my work in the laboratory. First, I synthesize the tapa resin on the tamarind matrix. Tapa resin on the tamarind matrix. Initially, 2-aminopropanic acid that we also call DL-alanin. I have taken the 0.1 mole was dissolved in the minimum amount of methanol to remove all the impurities present. That is removed with the methanol. And then I taken 0.1 mole of the epichlorohydrin for the chlorination of the before I synthesized. So I did the chlorination with the help of epichlorohydrin. That is also the same stoichiometry. That is 0.1 and 0.1 mole I have taken. And after this, a 0.1 mole of NaOH, sodium hydroxide, was added in the same stoichiometry, and stirring the same process for chlorination about 5 hours for the magnetic stirrer only, and left behind the overnight. And the second step of my synthesis, I took 0.5 mole of tamarind powder, that is the natural polysaccharide, which is used as a matrix, and with the help of NaOH to show the to make the mixture basic. So that's why I take again 0.1 mole NaOH solution and add it to the 60 degree. And after this, I was added 2-aminopropanoic acid, and finally washed with the methanol and acid to remove the extra impurities in the synthesis. And finally, I synthesized the 2-aminopropanoic acid resin and filtered and dried. And I found approximately 100.6 gram. The resin weight is approximately 100.6. Or we can say that it is the yield of the synthesis. Finally, I take the FTIR. Finally, I take the FTIR, and it is found near. This is the OS band, and this is the at the OS band is found near the 3268 frequency, and 2900 to 2921 centimeter. That is the acidic acid CS frequency. Due to the carboxylic group respectively. This is the FTIR I have observed, and this is the SAM. I have taken the SAM of the micrograph resin surface. There is a contain some cavity like this cavity structure. These are the small cavities around the in the whole resin that show the absorption capacity. That show more and more absorption capacity. The surfaces are heterogeneous and have vast variety of structure and permeable. Cavities, due to this cavities, its structure is permeable and can pass to the someone and hold to the other one. That is the real. This shows, same shows the real absorbent structure of the resin. That I have synthesized in the laboratory, and I did the pH titration. Based on the pH titration, derivatives of tamarind, it is found most of the pH graph shows that uh, uh, pH graph shows that it is stands comes toward the basic side. As we are increasing the volume of NaOH with NaCl, NaCl, so the final pH is increasing. That shows the straight line curve. This is the straight line curve, and this is the final pH. This is almost straight line curve as we increase the volume of 1.1 NaOH in every ml, and this shows that pH is increased in the increasing order. So this shows that the resin is of basic in nature. And chelation of taper resin of copper and zinc, as I told earlier, that this resin is very much effective for the removal of copper and zinc. That is around this efficiency is 83% and 80% respectively in the round, as I discussed earlier. For the required pH of 2 to 8, appropriate volume of 2 molar acetic acid and sodium acetate, a variety of glass stopper and conical flask. The liquid was filtered after the magnetic stirrer, and the concentration was taken by the AS metal. So it is found that the most chelation is of the tapper resin for the copper and the zinc metal, respectively. Both are the heavy metal, and it is very.
Mr. Singh, please try to conclude your work.
Yes, sir, definitely. Finally, the conclusion of this research work is that this is the tapa resin is very economical, effective, and very cost effective, and also eco-friendly to the environment, and very much it is very much effective in the removal of heavy metals, especially copper and iron from the orgam industry or steel industries, or many other effluents which contains zinc and copper at a very effective. So we can use such type of naturally polysaccharide for the removal of copper and zinc heavy metals from the effluent. Thank you very much.
Yeah, Ishwar, thank you for your presentation. So, I'm audible now, Ishwarji?
Yes, sir. You are audible.
So, can you please tell me, like, for my inquisitiveness, that what is you have written tamarind or is it a product or some like we have imli? वो है ये.
It is a powder form. I crush the tamarind seeds, and that powder I I crush the kernel of tamarind and make the powder, and that is that polysaccharide I use as a matrix for the synthesis.
Okay, because in the above, can you please move the slide towards ऊपर वाली slide दिखाएंगे जरा एक एक करके ये जो आपने दिखाई थी अभी नीचे.
Which one, sir?
One which was having a table, I think.
This one.
Yeah, this one. So you have written pH titration of tamarind 2-amino propanoic acid. So can you please like little bit explain to the audience, like what is how come 2-amino propanoic acid, is it attached or it is just like bound to the tamarind matrix? Is it the case?
Yes, sir. 2-amino propanoic acid is a amino acid I have taken, and tamarind is the polysaccharide base or a matrix. We can say that it's a matrix.
Okay.
And first 2-amino propanoic acid is chlorination by the help of epichlorohydrin, and then I mix it with the tamarind at the 60 degree. And the
Okay,
final product.
okay, I got it. I got it.
Yeah.
Can you please suggest me another name for 2-aminopropanoic acid?
Also,
Because you have
DL alanine. DL
right,
alanine.
right, right. So
Yes.
alanine, because we usually do not use amino acids name like in IUPAC nomenclature. Na? So as an organic chemist, we are much more comfortable with the traditional names of amino acids.
Yeah,
Right.
yeah.
Very good
Yes.
presentation.
Yes.
You are doing a good job.
Yes.
So thank you very much. And Dr. Chan, we can move to the next one.
Okay. Okay. Thank you very much, sir.
Sure, sir.
Are we allowed for another because we are lagging, Dr. Chan, we are lagging behind the time. So I don't
Yes,
think we
yes,
would be having much time for
yes,
questions now. So
yes, yes,
we
yes,
can have only 1 or 2 questions. Maybe you
Mhm.
can ask or sometime I can ask, and
Yes,
that
sir, yes.
should be it. Right.
Yeah, fine, sir. So
Sir,
we
this is Dr. Akbar, sir.
no, Dr. Akbar, this is
Yes.
not your turn.
Yes, sir.
Not your turn. Our next speaker is Humeshwar Damodar Anand.
Yes, sir, I am audible.
Yeah. Dr. Akbar.
Fine, sir.
सर
Uh,
एक ये पूनम सिंह ने अपनी स्क्रीन शेयर किया है तो
ये पूनम Okay, Chana, am I audible to you? Punam Singh Bhati is sharing his screen, so can we listen to him first?
Yeah, sure.
Oh, okay. Okay, Punam Singh, just start your presentation. Punam Singh? Punam Singh Bhati, am I audible to you? Punam Singh Bhati, am I audible to you or not?
I think there's some communication glitch,
वो
sir.
unmute नहीं हो पा रहे शायद या
Okay,
Sir, Poonam Singh Bhati is muted herself. She is
okay,
not.
okay. आप देखो होस्ट को म्यूट अनम्यूट कर सकते हो सर, आप इसको अनम्यूट कर सकते हैं यहाँ से पूनम सिंह भाटी नहीं हो रहा
Yes, sir. Yes, sir.
पूनम सिंह
Yes, sir.
आई थिंक we will hear your call later because there is some issue with you. We are not able to listen you very well.
That will go, sir.
Fine.
Poonam, you have joined from 2 devices, I think.
Yes, sir.
You have joined from
Now
2
go to-
devices.
What's going on?
So that is why it is
Yes, sir.
Now it's good. It's good. Poonam, Mr. Poonam is good now. You can go ahead now.
Yeah, we can go ahead. Just do it quickly. You tell your work.
Just try to complete your work within 7 to 8 minutes so you can give sufficient time to all participants.
आवाज इसकी कम करो, बंद कर दो इसकी फोन की. Yes, sir.
There's some issue with Mr. Poonam, sir. Better to move to the next presenter, sir.
Okay. Punam Singh Bhati, we will listen you later.
Yes, sir.
We are just, I think we are just going to going with our next speaker,
Yes, sir.
Mr. Humeshwar Anande.
yes sir, I am audible.
Yes. Okay. इनको जरा पूनम जी को mute करो.
Sir, my screen share. My screen is visible.
Yes.
Okay. Sir, I am audible and visible.
Yeah, you are very much audible on it.
Okay, sir. Good afternoon, all the respected juries, professors, and all the researchers. I am Mr. Rumeshwar Anande. As a research student, I am presenting on my topic in kinetics of a rapid chlorination of regioisomer of cresol by an enchlorosuccinimide in aqueous solution using rotating platinum electrode in a 2 days national 3 days national conference international conference. My supervisor is DM Chaple. So I give start my introduction. This is the outline of my presentation. Abstract, introduction, experimental, result in discussion, conclusion, and the references. This is my abstract. In this study, uh, the, the hallucination reaction is very much rapid. Therefore, the regioisomer, the hallucination of regioisomer cresol, that is specific the chlorination of cresol in an aqueous medium by using the NCS in potassium nitrate as a supporting electrolyte by using rotating platinum electron, we elucidated the specific reaction rates of the chlorination of ocresol, mcresol, and precresol. How we found 165, 5491, and 339 per mole per second at 25 degrees Celsius. And I also found out the thermodynamics parameters such as frequency factor, energy of activation, and entropy of activation. The introduction part, the cresol is the organic compound. This is also commonly called as the methylphenol. And the chemical structure of methylphenol having the cresol having methyl group substituted on the ring of phenol. This is the on para position, ortho position, and meta position. So this is the structure of cresols, isomers of cresols. The rotating platinum electron has very much used much less frequently than the dropping mercury electrode in a voltammetric. The halogenation compound play a very important role in organic synthesis. They are often used in the preparation of organometallic reagent. They are also used in the industrial intermediate in manufacture of agricultural, agrichemical, pharmaceutical, and other products. Due to the rapidity, these reactions cannot be studied by the conventional statistics. So in this present, we use rotating platinum electrode to quantitatively estimate the reactivity of regioisomer of cresol in aqueous solution by using the N-chlorosuccinimide as a chlorinating agent. The kinetic parameter of three reactions studied a quantitative justification of speculated reactivity of regioisomer of cresol. This is the approach in this synthesis. Green chemistry principle are inherently followed in this investigation. The experimental portion is analytical grade chemicals of isomers of cresols and N-chlorosuccinimide. And then in the experimental studies, we have two types of electrode are present, mainly the rotating platinum electrode and then saturated calomel electrode. The rotating platinum electrode were constructed in the laboratory. It consists the inverted T-shaped glass tube having 50 cm long and 5 mm diameter filled with the mercury. About 5 mm platinum wire protrudes T-shaped from the T-shaped glass tube. A copper wire is dipped in the glass tube. Electric contact. The assembly is mounted on the pulley and the rotating speed is 600 rpm constantly, that is by synchronous motor. Only NCS field diffusion current proportional to is constant at RP. We set the 0 volt versus. Therefore, the course of the reaction can be followed by monitoring the concentration of unreacted NCS from measurement of the diffusing current. So this is the calibration. Up before the start the measurements of current, these calibrate the NCS with various concentration. So this is the calibration curve at various temperature, and after that we starting the measurements, kinetics measurement. the equivalent solution of NCS isomer cresol containing 1 into 10 to the power minus 2 potassium nitrate as a supporting electrolyte at 25 degrees Celsius. After attaining the some constant temperature, that is the 25 degrees Celsius, we rapidly mix in 250 ml cell containing RP and SC simultaneously. Top was started. Then NCS diffusion current due to the NCS reduce at RP measure galvanometer depletion with lamp and scale arrangement. This galvanometer depletion is concentration unreacted NCS were determined at the various intervals of time. Then the result in discussion, they plot the reciprocal of concentration of NCS versus the time is satisfactorily linear in each isomer of cresol. It indicates that the chlorination of isomer of cresol by NCS in aqueous solution is first order with respect to each reactant, and hence the overall reaction is second order. The slope of given is specific reaction rate. The specific reaction rate of chlorination of O-cresol, P-cresol, M-cresol by NCS in aqueous solution at 25 degrees Celsius found to be 165, 5491 and 339 per mole per second respectively. This seen in the following tables. That is one of the table of O-cresol. In this case, this is the time, this is the diffusion current. This diffusion current is constantly reduced, and this is the concentration again, this is the reduced. So this is the concentration of unreacted NCS, and this is the reciprocal of the concentration of NCS. And this is the plotting the graph with reciprocal of concentration of NCS versus time. Okay. So this is the straight line graph. So the reaction is second order. Hello, I am audible, sir?
Yes, you are audible. Just go ahead.
Okay, sir. This is the M-cresol. Again, the time and then galvanometer and concentration of NCS. This reading all the readings at 25 degrees Celsius. The concentration of M-cresol 5 into 10 to the power minus 6 molar, and the concentration of NCS also same. And this is the supporting electrolyte use potassium nitrate. This concentration is 1 into 10 to the power minus 2. And this graph plot against the reciprocal of concentration of NCl and versus time. So this is also show the straight line. So these follow also the all these three reactions show the straight lines graph, and the slope of this used for the specific reaction rate. So this is the specific reaction. The specific reaction rate is 5491 for the M-cresol. This 165 for the O-cresol, and this is 339 per mole per second for the P-cresol. So after the three experimental setup, these experiments are repeated at various temperature from range 15 to 30 degrees Celsius. We determine the thermodynamics parameter. See, some thermodynamics parameter are shown here by calculated by this reaction. Initial concentration is shown also in the given table. Then specific reaction rate of this sum I also told already. I also told and show. This is the activation energy. This is frequency factor. This frequency factor is in this case, this is related with the structure. So this relative, this is the much more frequency factor of cresol. This is the lesser, and this is medium. So the entropy of activation in the below 7th row. So the M-cresol is having a minus 87.7, and after that, this P-cresol is having minus 46.1, and then O-cresol is minus 39.68. So activation of entropy activation is much more negative of M-cresol. That is the reactivity of the M-cresol is much more than the P-cresol than the M-cresol. We are seen here. So this is the study of relative reactivity of the isomers of cresol. So this show the reactivity in the.
Please conclude, Mr.
Okay, sir. Okay. This is the mechanism of the P-cresol, O-cresol, M-cresol, and P-cresol halogenation with NCS. This is the conclusion. The chlorination of isomer of cresol NCS aqueous solution yield good chloroderivative of cresol. This is the first order kinetics in cresol and first order kinetics in NCS. The overall kinetics is second order. The observed reaction is moderate negative entropies of activation. Indicate there is a formation of intermediate complex which is rate determining step. Thus, the relative speculated reactivity of chlorination of cresol isomer by NCS in aqueous solution is obtained in these studies. This is the references, and then thank you so much.
Excuse me, sir. Sir, there is a question, please. Can you? Sir, hello.
हाँ मैडम.
हाँ जी सर. सर आपके केस में ना एनर्जी ऑफ एक्टिवेशन जो है वो पॉजिटिव आ रही है. फ्री एनर्जी ऑफ एक्टिवेशन. तो व्हाट इज इट सिग्निफाइंग सर?
एक्सक्यूज मैडम.
सर आपने वो ग्राफ दिखाया था ना अभी, सॉरी टेबल.
हाँ.
उसमें फ्री एनर्जी ऑफ एक्टिवेशन आपके पॉजिटिव है तीनों केस में. हेलो.
हाँ मैडम.
हाँ जी सर, वो ग्राफ में जो आपने अभी ग्राफ दिखाया था ना सर, सॉरी ग्राफ का जो टेबल था ना सर एक.
Mr. Please show your the slide
हाँ
in
जी.
which
Smriti,
table is there.
Smriti,
जी
actually,
जी
you
सर,
will not be
ये
having.
वाला सर, इससे इससे पहले वाला जो था. हाँ जी ये सर. इसमें फ्री फिफ्थ नंबर का जो है ना सर, फ्री
Smriti,
एनर्जी ऑफ एक्टिवेशन.
हाँ हाँ
ये सारे में पॉजिटिव आ रहा है ना सर, जैसे ऑर्थोग्रिजोल, मेटा और पैरा में तीनों में
हाँ
पॉजिटिव है.
हाँ मैडम.
तो सर डेंसिटी डेल्टा जी तो नेगेटिव होनी चाहिए स्पॉन्टेनिटी के लिए. तो फिर आपका प्रोसेस स्पॉन्टेनियस कैसे है, मतलब जो ये है.
तो इधर इसमें एक्चुअली हमने जो किया है ये मेन इंटरेस्ट जो फोकस है वो एनर्जी ऑफ एक्टिवेशन पे है. ये जो माइनस दिखा रहे हैं इसमें से हमने रिएक्टिविटी कैलकुलेट की है.
सर
तो ये
इंट्रोपी तो सिर्फ वो उसकी
Smriti,
डिसऑर्डरनेस बताता है ना.
Matichand, am
सॉरी
I audible?
सॉरी, आई एम सॉरी टू इंटरप्ट यू सर.
No.
मतलब
Smriti, I'm Pankaj Khanna speaking.
जी सर.
I just wanted to convey that first of all, whenever we are in a group or in a presentation,
जी सर.
like you should be asking the questions and you should be asking the concerned person first. Like कि आप मैं पूछ सकती हूँ नहीं पूछ सकती.
सॉरी आई एम वेरी
No,
सॉरी
not a
सर.
problem.
सर पता है
But
क्या सर, ये
we are
ऑफलाइन में
actually
ऑनलाइन
having.
में.
नहीं सुनिए, we are
जी सर.
having a serious shortage of time because I
ओके
was told that this presentation part would be over by 5:30. Dr. Chand
ओके
would correct
ओके.
me. I was given the time for 3:50 to 5:30,
जी
and
Yeah, sir.
we have
350 to 550, 530.
5:30, and we
5:30.
have one more presenter added up. Earlier it
ओके
was
ओके
13 people, so we cannot take such long questions. I
जी
absolutely take your concerns, and like you must be very much curious about
जी
what is being
थोड़ा
done
सा.
now. So
हाँ
this
जी.
is the problem with the online part, that we are
हाँ
not
जी
able to connect to the speaker directly. So we have to take
बिल्कुल.
into stride, like we have to take into account that, and we have to move on. Please, I'm so sorry.
ओके
So
दिस सर.
Humeshwar, like whatever she's asking, I'm skipping that. I just want to ask one basic question, that how come like this order you are showing na here, can you interpret this order for me? Like the same page. Yeah.
yes sir. This is
No,
the
the earlier page, the same page, the same slide. You're saying from observed kinetic and thermodynamic data, the relative reactivity of the chlorination of isomer of cresol is. So you are saying that metacresol is most reactive.
yes sir.
So can you please elaborate in just like 15 seconds how you have reached that how can you explain this order? I could not get your order from the table like what you said earlier. Please repeat it just in 15-20 seconds crisply. Have you got my question?
Yes sir.
Yeah, please.
Sir, in this case, the negative entropy of the activation obtained in all the three isomers, the activation energy of these M crystal, that is the meta crystal, is much more negative, and this indicate that the substrate, that is the
Let me,
mi-
Umeshwar, let
methyl-
me rephrase
uh,
my question. Out of the 7 points you have given here, which point you consider is the best to explain this reactivity order? Let me rephrase this question. Which point is the best one? Quickly.
we
What are you taking into account? Either the entropy of activation or free energy of activation. So I think that would
entropy
answer Samriti's question also, that
Yes.
why things are going like that.
Mhm.
we are concluded from the entropy of activation.
Entropy of activation, which is the most negative. So you are taking
Mhm.
into account like,
Most
and
active.
how could you correlate with the K value? What theoretical aspect you are taking into account? The K
Yes,
value and the entropy of activation. If say this group is for all chemistry people and I am an organic chemist, I need to understand, or you are teaching in somewhere. So how would you explain that this K is the rate constant? Na? What is K?
yes, yes, sir.
So
K
how
is rate
come
constant.
K is related to all these parameters you have written here? So we can understand that initial reactant concentration, we read it in rate law and everything. Reaction rate you are writing here. So that is the reaction rate which is maximum 5491. यही तो आपका K है ना? मेटाक्रेसोल का सबसे ज्यादा है. तो
Yes,
ये activation energy we know it from Arrhenius equation we related. But ये जो नीचे वाले जो parameters आपने लिखे हैं,
yes.
have you given, have I missed any equation which are showing the relationship between the rate constant and these factors?
सर वो इक्वेशन डेल एस इक्वल्स टू आर एल एन के माइनस एल एन ई के
वो
टी
आपने शो किया है क्या प्रेजेंटेशन में कहीं
नहीं
पे?
सर इधर शो नहीं किया
इधर शो नहीं किया. ठीक है,
नहीं.
ठीक है. थैंक यू उमेश्वर, थैंक यू सो मच.
ओके
थैंक यू.
थैंक यू सर थैंक यू.
So I would request all the participants that please, because of the paucity of time and otherwise also because we have been given 10 minutes for each presentation. So there is only possibility of one question, either I can ask or other people can ask. So
Okay.
I'll keep it to maybe myself or Dr. Chand only.
Okay. Yeah, sir. If possible, then I want to request to every participant, sir, just try to conclude
Yeah, please
within
complete
6
it
to
because we
7
cannot
minutes.
go on and on. Right.
Okay.
Dr.
So
Chand, we can
our
move to next one.
yeah, sir. Our next speaker is, I think, Aisha Pandey.
Good afternoon to all of you.
Yeah, good afternoon. Please, sir.
So myself Aisha Pandey from GLA University Mitra, Department of Chemistry. Today I'm presenting my topic synthesis of cobalt second transition metal ion complexes with diamine and dicarboxylic precursors and investigation of their electrochemical behavior. So the content which I cover is introduction, the aim of the study, chemical reaction, result, FTI data, and UV visible spectroscopy, and comparative study with a standard drug, and synthesis part, conclusion, and references. So first we talk about introduction. Nowadays, people are more aware about environment and health issues. There is a great concern between industrial environment organization for the development of technology for the uses of two keys and disease the pollution. In the last century, chemists were able to synthesize some possible chemicals only, but the subject of toxicity and ecotoxicity has not received much attention. The exploration of macrocyclic compound is gaining a lot of attention in different fields, including chemical, biological, medicine, energy, in which they might be used. About 50 to 60% of hospital deaths are reported due to the infection disease. The treatment of these infections are mainly based on the antibiotics. So focus on that particular part. The term macrocyclic effect was first introduced in 1969 by the scientists Cabanese and Mergem in copper second complex. And here is the complex which they perform. And here we are using two methods, template and non-template. So here we are using first template method to synthesize our macrocyclic complexes. The easy route for the synthesis is template condensation. And here's the reaction part. In part one, we are taking 1 mole of triethylene, triamine, and 1 mole of acetyl acetone in presence of COCl2 salt, and doing the reflex process at 60 to 70 degrees centigrade, and the formation of pentaeder macrocyclic complex take place. And another part, we are taking the same amine, and we can replace the acetyl acetone, and taking the same salt COCl2, and formation of tetraeder salt take place. And for the calculation of percentage of carbon, hydrogen, and nitrogen, we can go through the CHN analysis. And this is the FTR and UV visible spectra of our molecule. Here is a pentaeder and here is tetraeder. And this is the comparative study with a standard drug, gentamicin. And for this part, we are going to take agar petri plates and do E. coli bacteria culture, and then put the disc around the circles, and load our drug. And if our drug is possible to kill the bacteria around which is present in the petri plate, then it is showing the antibacterial activity, and it is the comparative data. And this is the synthesis part, and these are the references. Thank you.
Thank you, Aisha, for such crisp presentation. Can you please show the starting slides? The one which were having structures. Yeah, this one. So can you
Yes.
the structures one? So you said that you use the 1 mole each of like, I would be asking just a basic question, a few basic questions.
Yeah. Yes, sir.
On the structure
Sure.
wala slide जो आपने equation लिखी हुई थी ना?
Yeah.
So can you please tell me the difference between you have told 1 mole and you are writing here 1 equivalent. So are you saying 1 equivalent like the molar ratio are equal, or why you are writing equivalence here? And when you were saying the presentation, when you while speaking out, then you were using the word mole. So what is the difference between the two?
Actually, sir, we are taking just like in a ratio part, that is like we are taking 1 mole of salt this, and 1 mole of salt this, and
We are taking like, you're saying that all the ratio of AB and the cobalt chloride are equal, same ratio mein you are taking it. That is what you meant.
it is depending on the actually molecular weight, which is molecular weight
No,
is
absolutely
mentioned.
everything depends on
Yeah.
molecular weight.
Yeah.
The meaning of saying and writing this is that all three are in equal. So can I know that okay, cobalt and chloride, one equivalent, right? And you're reflecting for 10 hours at 60 to 70 degree. Okay, pentaeder. Yeah. Can you please move to the next slide?
Yeah, sir, sure.
So this is the only way you have characterized the complexes, or you have
No,
used
sir. We go through the mass spectra also, and single crystal data, but this is we recorded from the journal publishing, and I'm also working on that particular theme though. So some part is working and some part is left. That is
okay. It's all right. Thank you so much, Aisha. Thank you so much. Very good.
Thank you, sir. Thank you, sir.
Dr. Chan, next one, please.
Our next speaker is
Sir,
Sonal
yes.
Rajoria.
Sir, Poonam Singh Badi, sir.
Sonal Rajoria.
पूनम आपको लास्ट में लेते हैं, ऐसा करते हैं.
जी
हाँ
सर, जी
पूनम
सर.
जी, आपको लास्ट में करते हैं, ठीक है?
Okay, thank you, sir.
Okay.
So, good evening, everyone. Is my screen visible?
Yeah, your screen is very much visible. Just
Is my screen visible to everyone?
Yes, Sonal, carry on, please.
Yeah. So, good evening, everyone. First of all, I am really grateful for this opportunity for making me a part of this conference. I am Sonal Rajoria from MNIT Jaipur. Would like to present my topic on the study on electrochemical methods for the remediation of heavy metals from the electroplating influence. Here we go just for the discussion of heavy metals which is found from the electroplating wastewater, and these heavy metals are very hazardous for our health, so it is mandatory to treat by applying some various methods. So for the next, this is the list of content under which I am going to present this conference, such as introduction, heavy metals in electroplating, effect of these heavy metals on the human body, electroplating wastewater treatment methods, and electrode material conclusion. So we know that today the environmental importance of water is considered essential everywhere in the world. So we can say that the water is the primary source for the livelihood, and due to the burden of these wastewater, so so we can see that the water scarcity in India. That's mean we ongoing the water crisis in India, which may affect nearly 1 billion people each year, and almost 75% of the household do not have drinking water on their premises. So this water scarcity is the essential severe problem that may be mitigated by reusing wastewater by applying a suitable treatment methods. So here we can see that on just by the report of the WHO, who can assume about more than 3 billion people of the world population will not have approach of the safe water by 2025, and this figure may be two-thirds by the 2050. So by the development of the industries, the many industries developed, such as electroplating industry, mining industries, and these industry contain a lot of heavy metal wastewater. In this industry contain acidic wastewater also. So in the electroplating, in the electroplating industries, so electroplating is a process which can be apply a metal coating on the another piece of metal by the electrodeposition process. This process is done just for enhance the property of the material or the property of the metal, which was enhanced by the extra coating over there. So we can say that about 29% of the toxic or hazardous waste come from these electroplating industries. So we can conclude the electroplating industry will generate a lot of heavy metals. So these are the heavy metals, basically the atomic weight, which can be ranged from 65 to 200. So these heavy metals are considered as very hazardous for the human beings. So the heavy metals such as which found from the electroplating industry, we can say that the copper, the coating of the zinc, so copper, zinc, aluminium, nickel, these are the heavy metals which found from the electroplating industries. So these heavy metals can be easily accumulate in the human body and can affect the kidney, liver, and these accumulation of these heavy metal by the food chain. So now we go through the various treatment methods for the removal of these heavy metal from the particular industry. So these method can divided into the physiochemical as well as the current method, which are the widely used recent year. So the physiochemical methods such as coagulation. So coagulation is the particular method applied, but this method is only for the higher concentration of these heavy metal. So now a time is it not feasible to remove complete removal of the heavy metals. The next one is the chemical precipitation. The another is the ion exchange. This method is also suitable for the heavy metals, but most of the heavy metals can be in range, the concentration between 10 to 100 milligram per mole. The another method that is membrane filtration. This is the widely used method for the treatment of heavy metal or removal of heavy metal from the particular industries. But the main disadvantage of this method, the falling of the membrane, and this method is the costly method. We can say that this method is not suitable at the higher at the higher or the industrial level. So now move to the current technology. In the current technology, we can say that the electrochemical methods widely used, or the recent methods which was used for the heavy metals treatment. So this is the number of heavy metals, number of methods such as electrocoagulation method, electroflotation method, electrophantom method, electrodialysis method, and the electrooxidation method. These are the type of the electrochemical methods which are recently used. So we work on the electrooxidation methods, and these methods is the environmental friendly or the cheap or the cost effective method to treat at the lab scale as well as the industry scale. This method is a suitable methods. So in the 19th century, the EO method was first developed for the treatment of the heavy metals removal from the particular electroplating industries. So basically, in this method, here are the two anodes was used. So one is for cathode and the another is for anode, are the basic parameters which is used in this process. So basically in this process, the refractive compound are converted into the water as well as the COT. That's mean we can say that the almost about 99% removal of the heavy metals by using this process. So this is the efficient and the environmental friendly method to remove the heavy metals. Basically, the heavy metals is a compound which do not easily remove by the conventional method, but these methods was very helpful for the removal, almost 99% removal of the heavy metals. So these are the advantage over the another method such as membrane, such as ion exchange, such as chemical precipitation method. These electrochemical such as electrooxidation methods having a various advantages, such as these method high separation selectivity. These methods is used for at any atmospheric pressure, can work at any temperature. This is a safe method. No or such
Please,
as
please conclude,
yes.
Sonal Rajadhan, please.
Yes, sir. So this is the electrode material, which is one of the most parameter by using this electrooxidation method. So these are the property when we selecting the electrode material, because this is the one of the most parameter by using these electrochemical methods. So I conclude my work. So from the literature survey, we can found that these electrochemical process was suitable a treatment of wastewater. So number of the heavy metals such as iron, zinc, chromium was effectively removal by using these methods. So number of the electrodes, which the electrode material are the main parameters which the process depends. The number of the electrodes such as stainless steel, titanium, etc. So by using a proper selectivity, electrodes must be selected. So future development, for the future we also hybrid this technology by the other techniques for the effective removal of this method. So these are the references. Thanks a lot. Thank you. Am I audible, sir?
Thank you, Sonal. Thank you very much. This is a literature review kind of thing you have done, or you are working
Yeah,
on
sir.
these? अभी work कर रहे हो
Sir,
आप इस पे?
sir, actually this is the literature survey, but basically in our research area I have published many papers for removal of the zinc, chromium, nickel. So I published my research work in a reputed journal
Why you
like
have not shown it?
Journal of Environmental.
You
Yes,
should have
sir.
shown the results also. If you have already published,
But,
then that is not a problem. And you should have included those. Anyways, not a problem.
okay.
So you should
Okay,
always
sir,
use
but I
if
just convey my review. So
no, that is not a problem. We can show anything. Conference is just gaining something out of जो presentations होते हैं वो सिर्फ knowledge gain करने के लिए
sir.
होते हैं और नई चीजें जानने के लिए होते हैं. तो अगर मेरे को ये नहीं पता तो
Yeah, sir, but
good enough. But अगर आपके पास है कुछ काम, So it is always good that
जी,
you
sir.
share a like brief idea of what you have done. Even if you don't want to show all the things or unpublished work or something like that, you should show the
Okay,
published
sir.
work, and people would be interested in it. So it will help you later on, like if somebody is working on that, so it will help other people by taking your papers into consideration, and that will increase your
Okay,
citations
sir.
also. तो पेपर आपका
Okay,
पहुंचेगा ना
sir.
दूसरे
I
लोगों
will.
तक, तो वो भी फायदा होगा, और
जी,
जिसको
जी,
चाहिए
sure,
काम,
sir.
मान लो यहाँ पे 15-16 लोग बैठे हैं, तो उनको अगर वही सेम
जी,
काम कर
sure.
रहे हैं तो वो उसमें इंटरेस्टेड हैं, तो उनको आपका पेपर मिलेगा उससे. तो थैंक यू सो मच.
Okay, sir. So,
तो
thank
डॉक्टर
you,
चांद,
sir.
नेक्स्ट वन प्लीज.
Till next time. Okay, sir. Thank you, sir. Thanks a lot.
So
वेलकम.
our next speaker is Miss Trisha Samanta. Trisha Samanta.
Yes, sir.
Please share your
Yes,
please
sir.
share your screen.
So is my screen visible?
Yes, please, sir. Just go ahead.
Okay. So good afternoon, everyone. Myself, Trisha Samanta, PhD scholar under working under Dr. Nazneen Nara Begum, Vishwabharati Shantiniketan. So and I'm going to talk about the exploring the fluorescent flavonoid-based antioxidant highly versatile viscosity probe. So we know that fluorescence spectroscopy is highly sensitive tool for an insightful analysis of the physicochemical processes related to the biomolecules like enzymes, proteins, nucleic acid. Intrinsic fluorescence activity of some molecule changes with the alteration with their microenvironment like polarity, viscosity during the interaction with the biotargets, which makes this molecule more suitable for detection of this toxic metal ions, subcellular protein imaging, probing amyloid fibrils, and many other disease conditions. Abnormal viscosity, fluid viscosity is an important factor which is associated with variety of functions and disease both at the cellular as and organismal level. So changes in the membrane viscosity affect the cellular signaling pathways and also associated with various diseases like cell malignancy, Alzheimer, and many other. There are some diseases like hypertension, hyperviscosity syndrome, diabetes, acute leukemia, polycythemia. All these diseases lead to abnormal intracellular changes in the viscosity. So detecting these abnormal changes in the viscosity of the cell can be a preliminary tool for detection of a disease condition. In recent times, small molecule has emerged as an effective probe for probing various disease. One such class of small molecules are known as flavonoids. These are ubiquitously exist in the vegetables, fruits, beverages, and other plant-derived food. These are highly antioxidant. They have characteristics chromophoric and fluorophoric behavior. They can be synthesized easily in the laboratory, and moreover, they can behave as a molecular rotor. So my objective is here to explore some synthetic flavonoid analogs with characteristic photophysical activity and free rotatable bond as a viscosity probe. This molecular rotor like flavonoid molecule can show TICT type of phenomena, which was explored to access the viscosity probing activity towards solvent with different viscosity gradient and biological fluids. Molecular rotor are those molecules which can generate TICT state. So when they generate TICT state and upon photoexcitation, they relaxes by radiative relaxation as well as non-radiative relaxation. But and 3-hydroxyflavone analogs, the analogs which I have used for my studies, 3-hydroxy analogs also have free rotatable bond. So due to this free rotation, they also generate TICT state. But when they enter in a viscous medium, this TICT state is not generated and the molecule attain planarity. The rotation stops and molecule attain planarity. So that's why it relaxes only by radiative relaxation, that is the fluorescence. So I have selected few molecules which differ in the structural flexibility. Those are HMDF. I have short named as HMDF, HSC, and HSF. These viscosity probe I have synthesized by following the scheme and characterized by using HNMR 13C and HRMS physicochemical data. That is for spectroscopic the data. So all the fluorescence spectroscopy has been recorded for all the three compounds in a solvent system, that is ethylene glycol and glycerol solvent system, in different viscosity gradient, which are mentioned in the table here. So we have observed that HMDF has showed a single emission at 380 nanometer with a band maxima at 484 nanometer. So on gradual increment of the viscosity of ethylene glycol and glycerol solution, the HMDF showed enhancement of the fluorescence intensity. The log intensity versus log viscosity graph has also been plotted. Through this, we have calculated the slope, which tells us the viscosity sensitivity of that molecule. And in HMDM, a chromon ring and a phenyl ring is connected with a rotatable single bond, whose rotation restriction helps HMDF to attain the planarity. In case of HSF, we have got a single emission. We have got a single emission at 340 nanometer and a band maxima at 450 nanometer. Stroke shift here is calculated 86 nanometer. So in HSF, a chromon ring and the phenyl ring is connected with two rotatable single bond, whose rotation restriction helps in attaining more viscosity sensitivity than HMDF. Similarly, in HSC, showed a single emission at 320 nanometer with band maxima at 423 nanometer. Here, the stroke shift that is calculated is 101.4 nanometer. So HSC is more flexible than HMDF and HSF, as it contains three rotatable bonds, and imposing the structural rigidity by restricting this bond rotation in viscous medium showed high viscosity sensitivity. So all these observations I have summarized in this table. So where I can see that by increasing the structural flexibility from HMDF to HSC, the viscosity sensitivity has also increased. So more the flexible structure, more is the viscosity sensitivity, which I can conclude from my observation. And also HSC has shown the larger stroke shift. Larger stroke shift also correspond with a good molecular rotor. So I can say that HSC is a good viscosity sensitivity as well as good molecular rotor. So high viscous solvent impose a rotational restriction and make the structures planar. Thus, natural TICT is hampered. Upon photoexcitation state, this motif has the unique ability to relax from the planar state via fluorescence emission. The viscosity probing efficiency of HSC was further explored in many other medium. We have selected here two micelle medium and one is mucilage medium. So micelle medium, we have used PVP and PEG, where we have made different concentration solution. With high concentration, we have observed, we have recorded the viscosity, and we have seen that with increase in concentration, the viscosity has also increased. And when we have checked the spectroscopic data, we have came across that with increase in viscosity, the fluorescence intensity of the molecule has also increased. Similarly, in case of mucilage we have extracted from Ebelmoschus esculentus, commonly called as okra. From there, we have extracted the mucilage, and we have.
Teresa, try to conclude, please.
Yes, sir. We have extracted this mucilage, and here also we have seen that with increase in viscosity, the intensity of the fluorescence has also increased. So finally, I would like to conclude that this is an economic, low-cost, easy method for flavonoid-based viscosity probe which are non-toxic. We can find application in the living system. Structure is the key factor for the intrinsic fluorescence as well as the viscosity probing. Among the three flavonoids, HSC showed the highest viscosity probing activity in the solvent with different viscosity gradient, micellar mucilage medium. HSC has also showed synchronicity in its emission with the increased viscosity. So this change of intrinsic fluorescence activity of HSC is the presence of high viscous medium opens up the possibility of the application of this antioxidant small molecule as a fluorescence probe for various fatal diseases instigated by intracellular viscosity changes. Lastly, I would like to thank the organizing committee. Thank you, everyone.
Thank you, Trisha. It was so much work. Have you published some papers out of this whole work?
So out of this whole work, like I am going to publish. So I think maybe in 1 week or 2 weeks I will publish.
Okay, good. All the best for that. And can I ask, what do you mean by intracellular viscosity? Like you have written in the last line, fatal diseases, intracellular viscosity changes. So अगर आपको लेमैन को बताना है एक कि maybe because you are talking about diseases, you are talking about human body and like what is happening. So intracellular viscosity को थोड़ा explain करिए एक बार.
Okay, sir. So intracellular viscosity is like in our cell we have cell fluid. All the like cytoplasm and basically the plasma, that is the cell fluid. So what happens when any kind of disease, if the cell is diseased conditions, for example, I'm taking a very common example, that is diabetes. So in diabetes, what happens? Glucose level increases up. So when glucose level increases up, so that is the glucose is increasing in the blood. So basically, if blood is again a body fluid and in the blood cells, the RBCs, the glucose level increases. So when the concentration of glucose increases, so the fluid becomes thick.
Okay.
Like what we see in the honey.
Okay.
Just like honey, when like honey बहुत पतला हो जाता है और ज्यादा होता है तो वो मोटा होता है, अगर कंसंट्रेटेड हो तो वो मोटा हो जाता है. सो
Sure.
यही है कि डायबिटीज के केस में भी ग्लूकोज लेवल ज्यादा हो जाता है तो वो लिक्विड जो है, वो फ्लूइड है, जो सेल फ्लूइड है, वो मोटा हो जाता है. तो ये फ्लूइड जब मोटा हो जाता है, विस्कस हो जाता है, उस वक्त हमारा ये मॉलिक्यूल जो है वो ज्यादा फ्लोरोसेंस एमिशन दिखाता है.
ज्यादा
तो
फ्लोरोसेंस
उससे हम
देगा
डिटेक्ट कर
तो वो ज्यादा मतलब फॉर अदर पीपल आल्सो एंड फॉर माय लाइक नॉलेज. सो अगर ज्यादा
सकते.
थिक होता जाएगा, विस्कोसिटी बढ़ता जाएगा, तो जो आपके जो मॉलिक्यूल्स जो आप प्रोब की तरीके से यूज कर रहे हो, वो रिस्ट्रिक्टेड वाला जो है वो उसमें जो फ्लोरोसेंस का चेंज आएगा वो कम आएगा. लेकिन जो व्हाट आई अंडरस्टूड कि जो आपका तीसरे वाला है HSC, उसके अंदर क्योंकि बॉन्ड रिस्ट्रिक्शंस जो हैं वो बॉन्ड रोटेटेबल बॉन्ड्स ज्यादा हैं, तो उस केस में वो फ्लोरोसेंस के प्रति सेंसिटिव, इट विल बी मोर सेंसिटिव टुवर्ड्स दैट चेंज. दिस इज व्हाट आई एम
हाँ
गेटिंग.
सर, मतलब सर ये है कि हमारे ये मॉलिक्यूल क्या है, कंटिन्यूस, अगर कोई विस्कस लिक्विड नहीं होगा तो ये मॉलिक्यूल कंटिन्यूसली रोटेट करता रहेगा,
राइट
जिसके
राइट
कारण
राइट
क्या है, जब उसको एक्साइट कर रहे हैं, एक्साइट के बाद जब मॉलिक्यूल आ रहा है, मतलब डी एक्साइट हो रहा है,
राइट राइट
उसमें
राइट.
से क्या है, कुछ फ्लोरोसेंस में जा रहा है और कुछ ऐसी एनर्जी के हिसाब से निकल रहा है, मतलब पूरा पूरा फ्लोरोसेंस में नहीं जा रहा है.
नहीं नहीं, वो तो आप
बट
नॉन रेडिएशन डीके, जो रेडिएशन लेस डीके होता है, जो नॉर्मल डीके होता है, मतलब जो कि ऑन स्टैंडिंग एक तरीके से लैटिस लैटिस इंटरेक्शंस वगैरह जो हम पढ़ते हैं, वो बहुत सारी चीजों से जो होता है वो रोक रहे हो ना, अब उसको आप सारा फ्लोरोसेंस की तरफ लेकर आ रहे हो. दैट इज ओके.
जी सर,
या
सो वो
गुड.
विस्कस, जब विस्कोसिटी बढ़ जाता है तो वो रिस्ट्रिक्ट हो जाता है, वो सारा ही फ्लोरोसेंस में कन्वर्ट हो जाता है, नॉन रेडिएटिव कुछ भी नहीं
So this
रहता है.
all is
तो
novel
यही
work.
हो रहा है.
This work is novel.
Excuse me, can I ask a question, please?
Yeah,
Yes,
sure. You
yes,
can
please.
ask. Yeah.
सर क्या, एक्सक्यूज मी मैम, क्या आपके मॉलिक्यूल में एग्रीगेशन इंड्यूस इमिशन इनहेंसमेंट हो रही है जब आप विस्कोसिटी बढ़ा रहे हो तो?
यहाँ पे एग्रीगेशन नहीं हो रहा है. एक्चुअली ये जो मॉलिक्यूल्स हमने लिया है, यहाँ पे ये एग्रीगेट नहीं कर रहे. ऐसा है, हमारे
अच्छा
पास कुछ और मॉलिक्यूल्स भी है जिनको हमने डिजाइन किया है जिसमें एग्रीगेशन भी होता है, बट
अच्छा
पर्टिकुलरली ये मॉलिक्यूल एग्रीगेट नहीं कर रहे हैं, क्योंकि एग्रीगेशन
अच्छा.
करने के लिए पर्टिकुलर कंसंट्रेशन पे ही एग्रीगेट, बट क्या है, उस कंसंट्रेशन से पहले ही कि ये पूरा मतलब आई विल से सेडिमेंट हो जाता है पूरा,
सर तो
तो
मैम
एग्रीगेशन
विस्कोसिटी
नहीं
आप
करते.
कैसे बढ़ा रहे हो? सॉल्वेंट सिस्टम चेंज करके सॉल्वेंट सिस्टम को
जी,
थोड़ा सा बता
जैसे
मुझे ना
हमने इथिलीन
Ma'am, I
ग्लाइकोल और
think that
ग्लिसरॉल का एक.
I
अच्छा
think we have not
हाँ.
sufficient time to.
Yeah.
ठीक है, सॉरी सर.
No, no, it's okay. Dr. Chan, आपने ठीक बोला. थैंक यू त्रिशा, इट वाज अ वेरी गुड प्रेजेंटेशन. तो
ओके,
मैं जस्ट
थैंक यू
एक
सर.
चीज पूछना चाह रहा था कि नोवेल्टी आपकी जो है वो दिस होल वर्क इज न्यू, सारा काम नया है. ये काम तो कुछ हो रहा होगा इसमें फ्लेवोनॉइड टाइप जो विस्कोसिटी रिलेटेड वर्क तो
सर
ऑलरेडी
जी
एग्जिस्ट
जी
करता
सर,
होगा, बट द
इसमें
मॉलिक्यूल्स आर न्यू फॉर दैट.
यस सर,
बट द
मॉलिक्यूल्स आर न्यू
मॉलिक्यूल्स
एंड
आल्सो
दिस
वुड बी
वर्क
नोन
इज,
ना.
मॉलिक्यूल्स आर न्यू बट एप्लीकेशन फॉर दिस मॉलिक्यूल इज न्यू. मतलब हम,
ओके.
मैंने यहाँ
एंड
पे जितना दिखाया है इससे भी ज्यादा एक्सटेंडेड वर्क किया है सर, मैंने
no, no,
डायरेक्ट
obviously
बायोलॉजी में इन
we
सेल.
all do it. Like we show
यस
a
सर.
little bit less because टाइम कंस्ट्रेंट भी होगा. एक चीज जो मैंने जस्ट जाते जाते नोट किया, वो जो आपका HSC है, ये
यस सर.
स्ट्रक्चरल मतलब मिस्टेक करी है आपने स्ट्रक्चर बनाने में. ये तो फ्लेवोनॉइड नहीं लग रहा है, ये तो कोई फिनॉल लग
नहीं
रहा
सर,
है.
ये चालकोन है सर.
चालकोन
चालकोन
है
का
ये तो.
मतलब ये HSF का, HSF इज द फ्लेवोन एंड
उसका
HSC इज
ओपन
इट्स
स्ट्रक्चर इसका
कॉरस्पॉन्डिंग
इंटरमीडिएट
चालकोन.
है. इसका इंटरमीडिएट है वो
यस
ना.
सर.
पहले
यस सर.
वाले का
यस सर.
इंटरमीडिएट है. राइट.
यस
राइट.
सर. यस सर.
सो वी कैन जस्ट से लाइक कि फ्लेवोनॉइड से पहले उसका इंटरमीडिएट ज्यादा अच्छा काम कर रहा है. वी कैन सजेस्ट दैट कि
पहला वाला
सेंसिटिविटी लेवल.
इंटरमीडिएट सर, ये जो हमने सिंथेसिस में दिखाया है सर, ये बीच वाला HSC, ये वाला पार्ट हमने कलेक्ट करके इसको, मतलब हम चालकोन एंड फ्लावोन बोथ
No, no, it's
चीजों के साथ काम
very
करते हैं.
much appreciable that you extended what you were doing. You were not concerned towards the product only, and you लाइक यही तो मेन जो कॉन्फ्रेंस करने का त्रिशा होता है हमारा पर्पस, और हम प्रेजेंटेशन देते हैं, जो हम इतना ज्यादा कुछ बड़ा बड़ा बताते हैं सब कुछ कि हमने ये किया हमने वो किया. दिस इज द पॉइंट आई वुड लाइक टू अप्रिशिएट दैट व्हाट यू हैव डन, यू हैव नॉट टेकन ओनली द फाइनल प्रोडक्ट. बिकॉज हम यूजुअली क्या करते हैं कि जो हमने ड्रग बनानी है, हमने ये करना है वो करना है, तो हम फाइनल प्रोडक्ट के ऊपर ही एम्फेसाइज कर रहे होते हैं. बट जस्ट बिकॉज दैट यू हैव टेकन एन इंटरमीडिएट फॉर दैट सेम पर्पस एंड यू हैव आइसोलेटेड, तो आइसोलेट तो किया ही होगा, उसके बाद आपने उसको भी उस मैकेनिज्म में डाला. इट इज क्वाइट अप्रिशिएबल, आई अप्रिशिएट इट. So thank you very much. It was a very good presentation also. You did a good job.
Thank you, sir.
Thank you.
Thank you, sir.
Dr. Chan, next one, please.
So our next speaker is Muspika Sultana.
Yes, sir.
Muspika.
Yes, sir.
Muspika, just try to complete your work within 5 to 6 minutes. We have
Okay,
not
sir.
taken
थोड़ा
it.
सा जल्दी अगर हम वो करेंगे तो क्वेश्चंस ले पाएंगे हम, मुस्फिका.
हाँ बिल्कुल. अब जो प्रेजेंटेशन वाला है उसको
Am I
थोड़ा सा
audible?
शॉर्ट कर दो. या
Good afternoon, good evening, teachers and all the members here. So I'm Muspika Sultana, PhD scholar from the Department of Chemistry, NIT Silchar, under the supervision of Amarud Jaman sir. These are my topic is on the a novel green synthesis of CO2 nanoparticles embedded on the coconut husk biochar for photocatalytic removal of dyes. This my content includes introduction, synthesis, characterization, experimental work, conclusion, reference, acknowledgement. Since my work is on the water pollution, so pollution from various industries and agricultural practices has resulted in the release of contaminants that have severely contaminated fresh water. So these pollutants are non-biodegradable. So it results in the harmful effects into the aquatic environment and living beings, causing serious health issues. So conventionally, various techniques are applied previously, like solvent extraction, nano ultrafiltration, reverse osmosis, ionic chain sedimentation, electrolysis, chemical oxidation, biological treatment, etc. But these processes are costly, not efficient, and more utilization of time and energy is needed. So photodegradation come up with a great favor in this case. So because it is a cheap, low cost, simplicity of operation. And since for photodegradation, nano photocatalyst is needed, but nano photocatalytic, when used naked, can have tendency to agglomerate, and also it is because of stability and reusable problem. Some carbon-based materials needed, like biochar, graphene oxide, etc. This will give a surface area for the nanoparticles to bound in this surface. So for that, photodegradation will be much favorable and with the great efficiency, since biochar is contains many functional groups. So a synergistic mechanism will take place, which will easily degrade these contaminants. So first, for the synthesis purpose, I have taken coconut husk and I have grinded into fine powder. Then I have pyrolyzed to form biochar. And in conical flux, I have taken biochar plus cerium acetate solution. And after that, I have taken Labellus purpurus leaf extract 30 ml. And I have stirred for some minutes, dropwise I have added. Then NOE solution 5 ml I have used, and stirred for I have stirred it for 6 hours. And after that, I have washed and dried and to get the cerium oxide biochar. This cerium oxide biochar I have characterized with various techniques. First of all, with XRD. And when raw biochar is taken, a significant peak at 23.2 theta, it gives a peak because of the graphite's amorphous carbon structure. And for the cerium oxide biochar, it shows peaks at 29.68, at 33.07, 47, and 56 degree. And this peak matches well with the Jessipedia number. So this, from the XRD data, we confirm that the formation of cerium oxide biochar has taken place. And to further go with the FTIR data, I separately took the FTIR data of biochar as well as the cerium oxide biochar, and I've seen that at at the peak at 3000 to 3500 is because of the OH hydroxyl group and carboxyl groups. So the peak is present there. But the peak at 1000 to 1300 in cerium oxide biochar, it is intended more than the pristine biochar because of the formation of cerium oxide bond or cerium hydroxide bond, and the peak appearing at 1500 to 1700 centimeter inverse indicates the existence of C double bond C and C double bond O in bond in the biochar. The bands at 880 to 754 centimeter inverse is related to the stretching vibration of CH bond on the benzene ring, because biochar when pyrolyzed it forms a graphitic like bond. And after that, the same and TEM image, same and TEM techniques are applied. And from the same images, it is shown that biochar exhibited an irregular flat sheet surface where nanoparticles were distributed uniformly on the surface. And from the TEM image, it shows that the biochar and the nanoparticles are well dispersed in the form of quasi-spherical in size, and the average size of the nanoparticles is 20 nanometer as indicated from HR-TEM. And from UV-DRS, when UV-DRS is done in the pristine biochar, it shows no peaks, but when in cerium oxide biochar, it shows peaks at 290 nanometer, which is because of the cerium particles, indicating the impregnation of it on the biochar surface. Further, from it, band gap is calculated, and it is found at 2.92 the band gap of this material. And XPS, and from the XPS data, we have seen that carbon 1 spectra shows 4 peaks at 284, 285, 297, 289 because of several oxygen containing bonds that are formed with oxygen. And from O1S spectra, it shows 3 peaks at 531, 532, and 533 because of lattice oxygen due to hydroxyl groups and due to surface absorbed water. And cerium shows 2 peaks at 886 and 906 because of cerium, different types of oxidation stage of cerium. And the experimental
try
work,
to complete so we can take some questions.
and from the experimental work is taken done, and for the optimization parameter is then the experiment was run under direct sunlight when with different catalyst doses like 4 to 16 milligram per liter. The catalyst dose is changed, and the dye concentration is changed from 10 to 100 ppm. H2 doses is changed from 0.1 to 1 ml, and after and a 4 ml sample of the suspension was taken at regular intervals, centrifuged and measured by UV visible spectrophotometer. And from the graph, it is seen that for methylene blue, 2012 milligram has given much degraded product, whereas for brilliant green has degraded 10. Brilliant green, it is seen that 10 milligram per liter has shown much degraded products, because increasing the dose of the catalyst makes the catalyst surface more exposed, which increases the active sites and encourages production of oxidation radicals, so improves photodegradation performance. After reaching its peak, the turbidity of the solution increases, so prohibit the interaction between light and catalyst sites, and because of this, the degradation decreases after certain point. And when dye concentration is changed, it is seen that methylene blue gives 70 at 70 ppm, 74% degradation has occurred. And for brilliant green, it is seen that at 60 ppm, 97% degradation has occurred. But after that, the degradation efficiency decreases, because as dye concentration rises, so do the number of dye molecules which coat the catalyst surface. So penetration of UV light reduced, thereby decreasing radical generation. And when the effect of H2 is seen, it is seen that 0.2 ml gives high degradation efficiency. After that, the degradation efficiency decreases because of scavenging of OH radicals. And when the contact time is done, it is seen that at 40 minutes, the degradation of methylene blue has taken place, and 94% degradation. And for brilliant green, 97% degradation occurred in 30 minutes. And the overall above method, it is done
please, Muspika, please conclude. We have not sufficient time, so that we have
Yes,
number
sir.
of participants left.
Okay, sir. So in water matrices also we have taken the river, lake, taps, distilled water, and it's seen that degradation efficiency in river water is reduces in river water because in river water inorganic and organic components are there, so interference of this take place. And in reusability, you have also seen that 5 cycles the reusability test has done, and for the mechanism purpose we have taken for a scavenging test where different types of scavengers are used to see which one is taking place in the mechanism purpose. So in mechanism takes place a synergistic mechanism is involved where absorption of pollutants with biochar surface takes place and simultaneous degradation of dyes occurs through generation of electron hole pairs. So when light strikes a photocatalyst, electron transfer from valence bond to conduction band. These electron hole pairs then generate free radicals.
Muspika, actually I have to interrupt here now because we would be having no time for other participants. So I'm so sorry, but we cannot go on and on like that, na? और 10 minutes आपका
Yes, sir.
हो गया है.
Conclusion is there.
नो कंक्लूजन नहीं, मतलब आपको जो है वो थोड़ा सा मैकेनिज्म स्किप कर देना चाहिए था, तो कोई बात नहीं. एंड आई एम सॉरी बट हम क्वेश्चन भी नहीं ले पाएंगे अभी क्योंकि हमें और भी ज्यादा वो करना होगा. इट वाज अ गुड वर्क, आई हैव सीन इट दैट यू हैव डिग्रेडेड. एक जल्दी से चलते हुए मैं एक सवाल में ही पूछ लेता हूँ कि आपने डिग्रेडेशन होने के बाद क्या बन रहा है, मतलब सिर्फ यूवी और ये जो आप जो स्पेक्ट्रा ले रहे हो इसी से किया है या you have used another mechanism also, and have you found what degraded products are made in this case with the dyes?
Yes, sir. Like LCMS is done to see what product is formed. I have not included here, though. See how
Sure.
much the molecule is degraded.
Right. You have shown the percentages and the time taken for that. Thank you very
Yes,
much.
yes.
It was a very good presentation. Thank you. Dr.
Thank
Chan,
you, sir.
next one, please.
Next one is Sneha Naik. And Sneha, just complete your work within 5 minutes. We have not sufficient time.
Yes, sir. Good evening, everyone. I hope I'm audible to the dignitaries. Okay.
Yeah.
Sir,
Yes, Sneha, you're audible.
Yes. Thank you, sir. So let me skip all the introduction part and get back to the work. Let me introduce myself. I'm Sneha Naik from Department of Chemistry, MET University, Jaipur. And the topic of my today's presentation is green copper oxide nanoparticle as an effective catalyst for the synthesis of two substituted benzothiazoles. This is the outline of my presentation. Just to be skipping, I was supposed to introduce in nanoparticles, but I guess it is just a particle between 1 to 100 nanometer range. Just to brief up, synthesis of nanoparticles, two approaches, top-down approach and bottom-up approach. So like that, there are various methods we can prepare by physical and chemical. One of the newest method which has come up is biological method, considered to be the green method of nanoparticles. So why green synthesis of nanoparticles? The answers are here because it is simple, non-toxic, cost-effective, eco-friendly, avoids use of high temperature, pressure, and toxic chemicals as capping agent or reducing agent. Thus, risk of contamination is lowered. Now, coming to the heterocycle, that is benzothiazole. Benzothiazole is a condensed heterocycle wherein the benzene ring is fused with thiazole ring, and it exhibits many biological activities. That's why we have chosen in our work to synthesize this heterocyclic compound. Now, in literature, there have been several methods reported for the synthesis of this scaffold, but the classic method involves condensation of 2-aminothiophenol with either carboxylic acids or aldehydes in presence of an acid catalyst and an oxidant. So in literature, these are some of the mentioned catalysts which are used. Some of the procedures use very harsh reaction conditions, or sometimes it is stoichiometric catalyst amount which is used. Some of the procedures have also been included. The recent catalyst developed, that is nanoparticles, that is copper nanoparticle and zinc oxide nanoparticle. But still there is a need for, hunt and need for seeking more efficient and excellent yield, transformation. So I present to you my work. That is, my work is divided into two parts. One part is preparation of the green catalyst, that is green copper oxide, which is actually, we only have termed it, that is copper oxide nanocomposite with readily available biomass. Once we confirmed that this catalyst is formed, we have utilized it towards the synthesis of benzothiazole preparation. So materials and methods used for my work was waste peels of quinoa mandarin fruit, which were selected. These were collected from the local fruit stalls in the city. You take the fruit, you peel it off. The peels were dried in the oven at 70 degrees Celsius for 24 hours. And once it was dried enough, they were ground to quinopil powder. Once this powder was formed, we thought of using we actually treated it with the precursor solution, metal precursor solution, that was copper sulfate solution. So we took the copper sulfate solution. To that, we added about a gram of quinopil powder, which was prepared by the previous scheme. To that, we added dropwise with stirring the NaOH solution, and we got a sudden change in the color of the solution, and we got a dark color precipitate, which we consider to be as a dried the composite of copper oxide quinopil powder. So the same intent study shows that yes, it is the particles have been formed under nanoscale. The same shows that it is having a spherical agglomerated compound, and the same image shows that it is in the range of nanometer scale. After the catalyst has been formed and characterized, yes, XRD also shows, that it is having the crystal structure matching with the copper oxide with reference to JCPDS file number 22. Now, result and discussion, I would like to extend that application of the catalyst prepared into 2-substituted benzothiazole. The model reactions or substrate used were 2-aminothiophenol, 2-nitrobenzaldehyde, and the catalyst. So we screened the different solvents, and we found that ethanol was giving us the effective conversion at a very high percentile. Similarly, we also tried with different catalyst fluorine. We found that 10 milligram of the catalyst fluorine gave us the effective conversion. And after getting that optimization reaction condition, we tried to extend these parameters to various substituted aldehydes, and we could prepare. So far, we have prepared only 7 of the benzothiazole derivatives. And the experimental procedure goes like this. You take an aromatic aldehyde, 1 millimole, 2-aminothiophenol, slightly in excess, 1.1 millimole, the catalyst in 10 milligrams, and 5 ml of ethanol. You reflux it for the appropriate time. Definitely, it was monitored on TLC to check for the completion. Once it was completed, the solution was filtered hot and purified via column chromatography. So whatever product was purified, so this was the model substrate. So this is 2-nitrophenyl benzothiazole. So here are the C13 and NMR spectra of it, which matches with the reference spectra available in the literature. We also checked for the reusability of the catalyst. So yes, it could be run up to 5 cycles, giving you excellent to good yields. And in conclusion,
we can't give you much time. So,
it's done. This is the conclusion, which I would like to mention. And I would like to acknowledge the people, references, and thank you.
Thank you, Neha. It was a very crisp and very good presentation.
Thank you, sir.
You have done a good job also. And may I know that the novelty of this catalyst for the particular reaction?
So the novelty is thing is that I actually am more into the green chemistry part. So and nanomaterials. So thing is that nowadays that nanomaterial synthesized from the biological biomass available is too much into the trend. So I wanted to use something which was readily available. So it was a fruit waste. We have used it, and we thought of rather than preparing a thing, we'll use like a composite and check for it. So whether it is going to be
it's absolutely fine what you have done. I can rephrase my question. Like, are the copper oxide like the nanoparticles you have prepared, which you have used from the quinopil you have used? So the procedure is new, or the nanoparticles are new, or the use of nanoparticles for this reaction is new?
So the new use of nanoparticle is the new. I would say that the use of, because copper nanoparticles have been used. Copper oxide with quinopil was never used for this transformation.
No, the copper oxide nanoparticles from quinopil has been prepared earlier also. Or you have done it for the first time?
For the first time, sir. Meaning,
so they were reported from other plant products, but other plant materials, but not from quinopil.
Not from the fruit waste, not from the waste materials, sir.
Not from the waste material. Okay.
Yes, sir.
Then it goes in some other territory. But and the procedure for you are showing right now on the screen. This is also like copper oxide has been known for this reaction as a catalyst.
Yes, sir. Copper oxide has been known, and there have been various things like they were been supported on silica, they were supported on carbon base. So I thought, why don't we support it on the material which we got from the bio waste material and check for the series for it. Like.
Okay.
So,
Okay.
yeah.
Thank you, Neha. Thank you so much.
Yes, sir. Thank you.
Okay. Next one is Rija Mariam Philip. Rija Mariam Philip.
Hello, good evening all. Am I audible?
Okay, okay, Rija, just complete me 5 minutes.
Yes, sir. Exactly. Hi all, I'm Risa Mariam Philip, a research scholar from Pondicherry University, here from the Department of Physics. Here I am here to present a topic, the development and biochemical sensing study of on DC sputtered bismuth incorporated zinc oxide titanium dioxide nanostructures for healthcare, environment monitoring, and food quality. So we are trying to develop a multiplex platform from wet chemistry PVD technique for usage of healthcare, environment monitoring, and food quality. Moving on. Is it moving? Yeah. Surface enhanced Raman spectroscopy is my method. Excuse me, am I audible?
Yeah, very much audible. Just
Yeah.
go ahead.
So the method is surface enhanced Raman spectroscopy, surface technique where you enhance your Raman scattering by a rough metal surfaces. So this is kind of a sensing platform which can be used for healthcare, where we try some biomolecules which can lead to some infections, and even in food quality assurance and environmental monitoring. So we are focusing on these three aims. And basically, all these source platform will be of silver or gold as the explored material. We are trying here for an alternative, a novel method, where we are developing a higher dielectric matrix of zinc titanate by wet chemistry route. And on top of that, a new material, or it's not a new material, a new platform from bismuth is coated by sputtering, and we have tried this particular substrate for multiple detection, ranging from various biological and chemical molecules, and we covered the entire spectra from UV to NIRG. Experimental techniques, the hybrid wet chemistry, physical vapor deposition method, we have developed zinc titanate structures through two precursors, in which it is titanium dioxide things will be produced, and in second precursor it will be zinc oxide. When you do the wet chemistry route, you will get the zinc titanate, zinc oxide and titanium dioxide nanocomposite, which you dehydrate using a hot air oven, grind it, and with the calcination, you will get two particular powder under two particular conditions. And that we have developed a home-built spin coater method where we put some quartz and glass substrate on which we will coat these particular powders what we fabricated. And again, we'll do the calcination, and these are the particular films what we developed on quartz substrate. On top of which, using sputtering, we use DC plasma of the bismuth to sputter some films, after which we anneal in a tube furnace, and this is the final substrate what we develop for the multiplex detection. On this, by normal drop casting method, certain analytes were prepared, and this is what multiplex detection normally looks like. These are the fabrication things. I'll go to the results and analysis discussion. Moving to the GXRD structural analysis, we found out the zinc titanate composite what we have prepared is an external structure with R3M space group in hexagonal phase, and with the lattice parameters and the angle with given, we are finding an orientation change from normal 33.24 angle to 35.29 degree, which can be due to the annealing process what is different, and this can increase the number of available density of free electron, which will further help you in the surface enhanced Raman spectroscopy earlier. And these are matching with the JCPDS number card provided, on top of which bismuth nanoparticles were coated, and that too we are finding it in the hexagonal phase with R3M space group, and these are the lattice constant. There can be possibility for the slight monoclinic phase of bismuth on top of SETI matrix because of the interaction of this oxide and bismuth together. but we are getting a normal orthorhombic phase. As you can see in the final XRD data on top, there is an orientation change even for the bismuth particles on top, which can increase the number density of free electron, giving up an enhancement mechanism in the future. So moving to the UV optical spectra, we are giving an optical spectra which is extending a tail up to NIR region. A combined SPR tuning is seen for the finalized sample with a bismuth. So you can cover the entire region. These are the maximum wavelength, whatever we observed for the absorption, and the energy band, what is calculated. The final one, BISET is optimized molecule, the film, where particular energy gap calculated and the wavelength corresponds to the SPR. This is a Raman spectra, which is for the structural analysis. It further confirms the zinc titanite hexagonal phase with the predominant 344 centimeter inverse, which confirms the longitudinal and transverse optical modes of these structures. And there are further some undefined peaks, which is due to the both annealing effects. And hexagonal phase, in particularly in metallic bismuth phase, is observed by the EG mode and A1G mode at 74 and 97 centimeter inverse in the particularly in the top graph. The application part, I would like to move on. It's nothing but an electromagnetic wave interacting with your matrix, and in which you are embedding a molecule through the chemical enhancement mechanism. You're getting the Raman signals. Yeah. The analytes discussed detected will be, I want to try in a multiplex detection range. So I have taken almost 9 molecules here, 4 from bioorigin, hemoglobin, D-glucose, 2 amino acids, tyrosine and methionine, and chemical molecules for the food quality and safety like malachite green, urea and starch, chemical molecules for environmental monitoring, rhodamin 60, methylene and thiocarbamide. These are the reference graph on the right side, where without substrate, you will not get any Raman signal. But when you use the substrate, you can sense the signal. That is through chemical and the electromagnetic enhancement mechanism happening. So you can see the particular enhanced signals on the left-hand side. This is particularly for the food molecules for urea, starch, and malachite green. You can see a dye degradation happening for the certain molecules. That is the photocatalytic effect of zinc oxide, titanium dioxide. So as a conclusion, this is magnetron sputtered bismuth on top of SETI nanostructures based search substrate will be a potential candidate for multiplex detection, and GXRD revealed the eccentricity site, which is a novel structure with a monoclinic and rhombohedral phases. And the optical study confirms the energy band gap correlation and the tailoring behavior of the SPR. Multiplex label-free detection, as you can see, of 9 molecules is done using a normal Raman spectrometer with 785 nanometer laser. And the photocatalytic degradation of the zinc oxide, titanium dioxide is seen. The occurrence of enhanced sensitivity due to combined electromagnetic and chemical enhancement mechanism is explained in this work. These results validate the potential in the fabrication of a universal search sensor device with diverse application in healthcare, food quality, safety, and environmental monitoring. Acknowledgement, and thank you.
Very good presentation, Risha.
Thank you, sir.
And, such a good amount of, and the amount and the work is also very good. So just keep it up. Just for like application part, like you have done a lot of work. So
Yes,
which
sir.
part you like the most?
Sir,
I'll
be
keep this screen on, right, while giving the answer.
Sorry,
right.
sir.
Keep this screen, this slide on.
Yes, sir.
Yeah.
Sir, I would be particularly interested in going to the biological molecules, sir, which I am doing the limit of detection part now, because I feel it's very important. The hemoglobin, D-glucose, all these molecules are the precursors for certain health ailments in our body. And we have succeeded in the limit of detection part also, up to even femtomolar level of detection. So I am particularly moving in that direction, healthcare.
Okay. So the next part, the last point I can make, because this is such an elaborate work you have done. So
Yes,
these analytes you have detected, are these detected qualitatively or quantitatively also? Like
this have been here I have shown qualitatively, but this has been detected quantitatively also, sir.
you have kept the variation of the concentration
Yes,
of the...
sir. Yes, sir.
Okay.
Yes, sir.
Okay,
Yes, sir.
great.
I would like to know the sensitivity of the platform which I need. So
Right,
I
right.
have done the quantitative.
Do you have any plans of like putting it into like people with electronics and all. So
Yes, sir. I would like to do for a device fabrication also.
Device fabrication,
Yes,
sure.
sir. Yes, sir.
Thank you very much. Thank you,
Thank you.
Rita.
Thank you, sir.
Very
Thank you. Yeah.
good. Dr. Chan, next one, please.
Okay, the next one is Sarita Yadav. Sarita Yadav.
Yes, sir. I am here, sir. Good evening, sir.
Okay, just share your screen and if possible, then try to complete your work within 5 minutes.
Is this available, sir?
Yeah, very much visible. Just go ahead.
Okay, sir. Good evening, everyone. Here I am Sarita and pursuing a PhD from MD University Rohtak under the supervision of Professor Meenakshi Sharma. Here I am here I am presenting my work, that is electrochemical construction of electrochemical biosensor, that is on for the detection of folic acid in pregnant women, that is based on a composite modified gold electrode. So because of lack of time here, I am just summarizing my work by taking not so much time here. As we all know, the folic acid is also known as the folate, that is a vitamin P, and this can be found in various green leafy vegetables, sprouts, fruits. But when we go for them for cooking, it can be easily destroyed. It is actually it is a water soluble vitamin that helps to the body to synthesize the red blood cells. So it is very essential for the human body, especially for the pregnant woman, and it is also necessary to prevent a major abnormality in baby's brain or the spine. And it is estimated that the normal body content of the folic acid is estimated to be 10 nanomolar to 30 nanomolar. And this is the emerging issues that every second pregnant woman is suffering from the deficiency of the folic acid. So folic acid intake is therefore folic acid intake via either it is via medicine or the fortified foods is essential for the pregnant woman that is suffering from the folic acid deficiency. So this is the goals of my study, and we go for that step by step. Here here I prepared the titanium dioxide nanoparticles by taking guava leaf extract as a reducing and the capping agent for the synthesis or for the preparation of the titanium dioxide nanoparticles by following Kumar et al. 2014. And for the preparation of titanium dioxide was confirmed by using UV visible spectroscopy, zeta potential, and transmission electron microscope. Here, by using UV visible spectroscopy, it was confirmed that the titanium dioxide nanoparticle showed maximum peak at 240 nanometer. That confirmed that the formed nanoparticles possesses good absorbance at UV region. And the size of the nanoparticle was confirmed by using transmission electron microscope, that confirmed that the nanoparticles are almost spherical in shape and having 50 nanometer size. And for the stability, to confirm the stability of the synthesized nanoparticle, the zeta potential was used to characterize this, and it was concluded that all the nanoparticles present in the prepared solution possesses minus 8.43 MB zeta potential value, which confirms that all the nanoparticles present in the solution possesses negative charge on their surface that prevent their agglomeration and hence increasing their stability. I also take the multi-volt carbon nanotubes as a composite, and by following the dispersion, their washing the dispersed multi-volt carbon nanotubes were mixed in EDC and NHS solution to activate their functional group. Here, the electrodeposition of multi-volt carbon nanotube and the titanium dioxide nanoparticles was done with the help of the 3 electrode system, that is the potentiostat on the clean gold electrode, and this modified electrode then dipped into the enzyme buffer that containing DHFR, that is dihydrofolic acid reductase, to immobilize on the modified electrode. Here the constructed DHFR multivolt carbon nanotube titanium dioxide nanoparticle modified gold electrode was used as a working electrode. When it was not in using, it was stored at 4 degrees Celsius. To confirm the electrode deposition and the immobilization of the electrode immobilization of the enzyme characterization was done. Here scanning electron microscope was used to confirm the deposition and immobilization of the enzyme. Here the bare electrode showed no any deposition of any other material, and here you can see the second figure that shows the composite nanotube and composite modified gold electrode, and the third you can see the globular like structure that confirm the presence of DHFR immobilized on the composite modified electrode. Now the response was measured, and it was seen that the maximum current of the constructed folic acid biosensor was obtained at 0.125 volt against the silver and silver chloride electrode that was used as the reference electrode. Now the optimization was also done of the constructed.
Please conclude me.
Okay, sir. Optimization was done by taking pH, temperature, and the substrate concentration was also checked. And here is the evaluation that was done of the constructed folic acid biosensor. Now the 11 limit of detection, 11.48 nanometer limit of detection was determined by using the formula this, and by taking the signal to noise ratio is equal to 3, and a good linear relationship was obtained, that was between 5 nanomolar to 50 nanomolar. Significance of the constructed folic acid biosensor: as per the WHO, each pregnant woman must be able to access the right care at the right time. So I employed my this constructed biosensor to test the folic acid in folic acid level in the pregnant woman's serum sample, and I collected it from my nearby medical. Sorry for that. Here is the collected data that we got from our constructed biosensor, and it was analyzed that the constructed biosensor have a good analytical recovery and also showed the good reproducibility capacity. Conclusion: titanium dioxide nanoparticles that have been widely used, actually it is an eco-friendly, clean photocatalyst, non-toxic and highly stable material. So it was employed for the work, and the guava leaf extract was used as the reducing and capping agent that help in stabilizing the nanomaterials, and the multivolt carbon nanotubes were they offer the good catalytic properties. Along with this, it also has great thermal and electrical conductivity also. And use of this green approach of synthesizing nanomaterials, this fulfills the requirement of large scale production, non-toxic to the environment, and low costly. And as we all know, the fruits of these emerging techniques made to improve the quality of life. We should all
Thank you, Sarita. Yeah.
Thank you, sir. Here is the future prospect that can be done on smart biosensors by constructing them. And here we say that prevention is better than cure. So every woman should take their nutritious diet. Here is this is the published work which I presented.
Great. When the paper has been this work has been presented there?
Yes, sir. Yes, sir.
Okay, great. Thank you so much.
Lack of time, sir, मैं ज़्यादा अच्छे से कर नहीं पाई.
नहीं, आपने पूरा बता दिया है, और lack of time की वजह से हम ज़्यादा question नहीं पूछ पाएंगे.
Yes, sir. Sure.
On to the next one now, because it is getting too late. Right.
Okay, sir. Thank you, sir.
Okay. Next one is Varani S. Varani S. Varani S. Okay. Okay, Varani, just start. Hello, am I audible?
Yeah, Dr. Chan, yeah, I think she has not unmuted herself.
Okay.
Please unmute yourself.
She unmuted already. Okay.
बोल नहीं रहे हैं.
Yeah.
Sir, am I
His
audible?
voice. Yeah.
Okay. So, good afternoon, everyone.
I think his voice is not very much clear.
No problem. So, am I audible now, sir?
Is it okay, Pankaj sir?
Yeah, she can start. We will see what is happening. आवाज तो बिल्कुल नहीं आ रही है अभी.
Sir, am I audible?
Now it's better. Yeah, you can start.
So, good evening, everyone. Myself, Barney from Tamil Nadu. And today I'm presenting the outcome of the annual computer science competition after hydrogen found in access. So, first of all, let's start what is sample. And it was
I think we are not able to listen. You.
I'm not audible
You are not audible.
now.
I think there is some network issue from your side.
Voice is too low. What आवाज आ रही है आपकी? But it is very less.
Oh, okay. Am I audible?
You can speak a little louder, right?
Yes, sir. Yes, sir. So, so that actually how and so if you just take one of the and break down into the pieces to understand the whole. So here we are after hydrogen and also at which is success as after hydrogen bigger forming success as well. So if we can mimic analog target for the coming from the development. So how we are going to
Sir, her voice is not clear, sir. We are not able to listen her.
so, am I audible now?
Now it's okay. It's okay now.
It's okay.
Yeah,
Am I
it's
audible
clear. Okay now. Yeah, you are clear. Your voice is clear now. You go ahead. You go ahead now.
So if you see this course, it has many cycle system in it. So one of the things for the chemistry cycle cycloaddition reaction. So I we have developed a cycle go to cycloaddition reaction, which is cycloaddition. And so if we are having this 4-pi and a 2-pi system, it can be a cyclohexane course. So easily to say somebody that we have also had in our spectrograph. Yes, yes, it is. So now we know that chemistry to prepare it. So with this, in a basic knowledge.
I think you are not able to get you, Varan. Your voice is not clear. So we can give the chance another speaker, if possible. Okay, sir.
Now am I audible?
Are you asking me, Dr. Chan?
Yeah. Can we give the chance to next speaker? Because
So let us just finish the content ना मैं जो है वो just देख लेते हैं एक बार. Although it is quite self-explanatory. What is she telling? So अभी तक जो समझ में आ रहा है तो उसको चलता रहने देते हैं. And let her finish. And Barani, please just try to be a little bit louder. I understand that is very difficult, but मैंने थोड़ा सा अपना जो है वो voice level भी बढ़ा लिया है. So please a little bit louder. Yeah.
Okay. So this is the abstract of our work that accepted by our group, and our work has started with the diagonal synthesis. First is like the butanol and butanol. In the first step, we have used double reaction followed by decarbonation that involving the protection of the butanol followed by the chlorination. In the combination of those two products in presence of copper sulfate and phenolphthalein resulted in the PN cross-coupled product. And then the cyclation is typically made with the use of palladium acetate and the benzene. Then further steps are carried out to deproduct the alcohol, followed by the oxidation to get our desired diol. Then coming to the aliphatic synthesis, this is basically
There is no voice now, sir.
from commercially available hexagens. So the aliphatic synthesis basically involves the protection of the hexagens followed by the euphilic reaction to get the oxidation. So now the combination of these two starting materials in presence of DPP or TMS result in the use of the product, which further reduce using the sodium borohydride and upon the use of selective receptor in fluoroesterification products. With this initial result, we have started our optimization where we have first utilized DPPO TMS and benzoic acid in toluene as a solvent prepared in the selectivity 4:1 and 95% financial selectivity. Whereas with the DPPO TMS, no product formation is observed. Whereas with bifunctional catalyst, the product is but the selectivity is very poor. Then they have moved to optimize the additives and figured out that 25 more % of benzoic acid is in selectivity. And after optimizing all the catalysts and additives, we have also changed various solvents and figured out the entry number 7 is the best optimization condition. With this optimization condition, we have explored the state scope of the reaction where we have three fluoro compounds followed by other halo compounds, and the relative series of the compound is also confirmed through the single crystal experiment. And let's we move to the metal and the OCF3 group and figure out the chemical properties superior in the metal group than the later one. Then we have also modified different British groups and framed this followed by different. We have also modified the protection group properties on this category and figured out that all is highly tolerable and giving excellent energy up to 99%. So after all these efforts, we moved to synthesize the synthetic application of our product and conditions. So here we have done the ionoesterification and it also resulted in moderate activity and the excellent energy selectivity. With the use of this conversion, we can also make further steps into the listed molecules with the help of the references given below. After all these efforts, again, there is also another reaction where we have utilized medium to create a use for the product, followed by the calculation, but the product does not form as standard status is given a set limit and effort. After all these efforts, we are proposing a mechanism and continuing through the enabling mechanism and leading to our major product and endo approach. Whereas with the endo approach, we are taking a minor product. So, with this, I would like to conclude that we demonstrate that the synthesis of novel techniques, fluorohydroquinone, and the absolute confirmed through the figure study. And these molecules are submitted to reactive activity in the microscope. And this is the paper that was recently published in the University of Asian Journal. With this, I would like to conclude acknowledge my service of post and use the for this financial support. Thank you.
A lot of work you have done, Bharani, and just can you please take to the first slide where you have done the synthesis?
This one, sir?
The first one, the before the animation just stopped, na? Earlier one. When you took 1 and 2. Yeah.
Okay.
The next one, right. एक बार पीछे लेकर जाओ और पीछे लेकर जाओ एक बार. Back. This is the first slide for synthesis.
This one, sir. This one, sir.
Okay. And the next one?
This is second one, sir.
So, because it was just in black and white now, so I just wanted to check. Okay. So you have done the like Wittig reaction.
Yes, sir, Wittig reaction.
Okay. So is this molecule isotin stable with this reaction?
Yes, sir, it's stable.
Stable. So, and
Yes,
what
sir.
was the yield of this reaction?
We are getting up to 60% yield in this case.
Up to
60% yield.
60%, good enough, right? Because
Yes,
my
sir.
whole PhD work was on this molecule only. That is why I was interested in. I have
Okay.
done a lot of work on isotin, and I'm still doing
Okay.
like I do the basic organic chemistry part of like synthesis and other base molecules I have prepared. Now I'm moving
Yes,
on
sir.
to some other part. So I was interested
Okay.
in this. This is a lot of work you have done. How you have characterized the stereochemistry of the molecules you have finally made?
To single crystal XRD, sir.
No, but all the molecules are giving single crystals. You have isolated all the final
No,
ones.
no, sir. Actually, in
So
isolation,
there should be some other ways also, no? Like doing the 2D
yes, sir,
spectroscopy,
NOE also,
HMBC, HMQC or something.
we have also done NOE studies, sir.
NOE.
Yes, sir. NOE
Okay.
studies also we have done for this.
Okay. That is all I wanted to ask. Right. Very good.
Yes, sir.
Good job.
Okay.
Yeah, thank you.
Thank you, sir.
Okay, our next speaker is Sulekha Sharma. Hello,
Yeah, hi.
Sulekha Sharma.
Are my slides visible? Am I audible?
Okay, just try to complete in 5 minutes.
Yes, Sulekha, you are
Yeah.
audible. Yeah.
My slides are visible, right?
Yeah.
Yeah,
Please carry
thank you
on.
so much. Thank you. So, good evening, everyone. I'm Sulekha from ICHE Bhopal, working under Dr. Amit Paul. So, the title of my talk is Tempo-Catalyzed Greener Electrochemical Dimerization of 3 substituted to oxyindole via 2 electron and 1 electron transfer pathways. So, before going into detail, first I would like to just a second. First, I would like to give a brief introduction about electroorganic synthesis, which is a rich playground for the synthesis of organic molecules, as it harnesses the electrode potential as a tool to oxidize or reduce a species by replacing the use of chemical oxidants and reductants, and therefore it avoids the production of huge amount of toxic waste, and it uses mild reaction conditions, and therefore it follows some of the principles of green chemistry. So the fundamental concept behind this electroorganic synthesis is that it consists of 2 processes, that is the electron transfer and the chemical process. In the case of electron transfer process, the substrate diffuses towards the electrode where electron transfer will take place, and which will lead to the generation of reactive intermediates, which will diffuse back to the solution where the chemical process of interest will happen to give the product formation. So the key to drive an electrochemical reaction is the application of potential. So on applying a negative potential to the electrode, the energy of electron increases and it reaches to a level where it will match with the energy of the substrate, and an electron transfer from electrode to substrate takes place, and this process is known as reduction. Whereas on applying a positive potential, the energy of electrons of electrode goes down and it will match with the energy of the substrate, where electron transfer from substrate to electrode takes place, and this process is known as reduction. So using these basic concepts, we targeted 2-oxyindole as our molecule of interest, as they have various applications in the synthesis of natural products such as polycanthine and chimonanthine. So we searched the literature and we found out that for the dimerization of this molecule, they have either used the chemical oxidants in super stoichiometric amount or uses metal catalyst with higher temperature. So in order to avoid the use of this chemical oxidants and metal catalyst, we charged this molecule in our electrochemical setup using these conditions, and we were successfully able to avoid the use of chemical oxidants and metal catalysts, and the reaction proceeds at room temperature. But there were certain challenges that were also associated with our electrochemical methodology, such as the use of large amounts of electrolyte, high potential required to carry out these reactions, and the electrode passivation, which leads to the more reaction time. Therefore, in order to answer these questions, we move from direct electrolysis to indirect electrolysis, where the electron transfer step is shifted from heterogeneous process to homogeneous process. And in this case, an electrochemically generated reagent, which is also known as mediator, engages with the substrate in a reversible redox manner, which will generate the reactive intermediates and leads to the product formation. So in our case, we targeted 3 different molecules with varying pK using tempo as a mediator at a constant potential of 0.8 volt with respect to IGHE plus at a room temperature, and by varying solvents and supporting electrolyte, we optimize the reaction conditions. And in this case, we optimize the reaction conditions by measuring the diffusion coefficients and the rate of the reaction. And surprisingly, we found out that the highest rate constant consists of this acetonitrile along with ammonium hexafluorophosphate as a supporting electrolyte, which gives us the highest yield of 75%. So after getting our best reaction condition, we also found a good correlation between the yield and the rate constant. So we
Ma'am,
found
if possible,
that
please conclude, ma'am.
Yeah, sure. So the rate constant increases, the yield of the reaction increases. Also, thereafter, we look into the mechanism of the reaction, and we found with these results that tempo OH is generating in the reaction as the peak at 452 nanometer get diminished when a potential of 0.8 volt is applied. So we propose the mechanism of reaction that first the tempo is forming this tempo plus, which will do a hydrate transfer with the substrate to form this cationic species, which will react with the enol form of the substrate to give this dimeric product. Similarly, we also charged this 3-alkyl 2-oxyindole for our molecule, and we were successfully able to get this dimerized product. Thereafter, we also charged this 3-alkyl carboxylate 2-oxyindole for our case, and we also get 68% of yield for this molecule as well. Also, we studied the kinetic rate constant of the reaction for these 2 molecules, and we found that the kinetic rate constant was highest for the 3-carboxylate 2-oxyindole, which does the hydrate transfer, and the rate constant was lower for the 3-alkyl 2-oxyindole, where only 1 electron transfer mechanism was followed. That is the radical mechanism. Also, we were successfully able to avoid the electrode passivation, which increases our yield of reaction. And in order to avoid the generation of waste and make reactions more greener, we were successfully able to recycle our electrolyte till 6 number of cycles. That is 75% of electrolyte was recovered after 6 cycles. So in conclusion, a sustainable tempo catalyzed dimerization of 3 types of 3-substituted 2-oxyindole with varying pK has been targeted, and electron transfer rate constant measurement has been proposed as an alternative for synthesis condition optimization. And low energy control potential electrolysis has been demonstrated towards the dimerization of these molecules. Also, this 3-carboxylate substituted 2-oxyindole followed the hydrate transfer mechanism, which is a 2-electron transfer mechanism. And this 3-alkyl substituted 2-oxyindole and 3-alkyl carboxylate substituted 2-oxyindole followed 1 electron transfer mechanism. And finally, we were successfully able to prevent the electrode passivation as well as recover the electrolyte
Thank you, Sulekha. Thank you so much.
Thank you.
Yeah, thank you so much. So I would like to pass on right now because we have crossed the limits.
Sure.
So thank you very much for the presentation.
Yeah, sure.
Okay, the next one is Dr. Akbar. Dr. Akbar. And Dr. Akbar, please complete in 5 minutes.
Sir. Is my screen visible, sir?
Yes. Please go on.
Thank you very much, sir, for giving me this opportunity to present my work. So, myself, Dr. Akbar, assistant professor currently working at the Department of Pharmaceutical Sciences, University of Kashmir. So, my topic of presentation is study of carbohydrate digesting enzyme inhibition guided anti-diabetic activity of metformin in steatosis-induced diabetic rats. So, starting with the diabetes. Diabetes, as you know, is a chronic disease that occurs either when the pancreas does not produce enough insulin or when the body cannot effectively use the insulin it produces. As you know, insulin is a hormone that regulates blood sugar. Hyperglycemia or raised blood sugar is a common effect of uncontrolled diabetes, and over the time leads to serious damage to many of the body system, especially the nerves and the blood vessels. As you know, the statistics is given here.
Akbarji, can I
fine,
please
sir.
request you, just because we have one more participant left, so
Fine,
can I
sir,
please
okay.
request you to just move on to your work, like you show
Fine,
your,
sir.
yeah. Thank you so much. Thank you.
Okay, fine, sir. So my main my main aim was to find out the anti-diabetic activity of mentha-arvensis allele fraction. So, sir, what I did, I took mentha-arvensis, I performed this extraction. After that, I did the allele fractionation of that aqueous extract, and I performed the alpha amylase and alpha glucosidase inhibitory assay on these allele fractions. So, what I find was that the chloroform allele fraction of aqueous extract of mentha-arvensis was having better activity than the dichloromethane allele fraction. So in results, you can see from the results that I performed the phytochemical analysis, which showed me the chloroform allele fraction contains saponins, glycosides, terpenoids, steroids, and flavonoids. Proteins and fats were also present. So these are the in vitro alpha amylase inhibition of the aparbose, the chloroform allele fraction, and dichloromethane allele fractions. So from the results, it is very much evident that as per ICHE is concerned, the chloroform allele fraction is having 3.65, while as the dichloromethane allele fraction of XX studies having ICHE value of 50. So these are the graphical representation of the percentage inhibition. So it is also evident that the chloroform allele fraction is much better or much efficacious than the allele fraction, other allele fraction. So that the toxic study was performed, and it was found that 200 mg per kg body weight was safe. And as per the guidelines, 1/10 of the toxic dose, safe dose was taken for the evaluation of anti-diabetic activity in streptozococin-induced diabetic rats. So from the results, what I found was that it is very efficacious. The chloroform allele fraction of extract was very efficacious as compared to the vulvenplamoid. So from the results, it's evident that also. So this is the bar diagram representation. So it also shows the efficacious activity of the gamma, that is the chloroform allele fraction of aqueous extract. So the last graph or last bar diagram shows us the body weight. So the gamma that also prevents the body weight in the diabetic rats. So this is the lipid profile. So lipid profile also confirmed that the chloroform allele fraction of aqueous extract was more efficacious than the other standard drug. So in conclusion, what I conclude is that gamma, that is the chloroform allele fraction of aqueous extract mentha-arvensis, it inhibits the alpha amylase and alpha glucosidase enzymes. These are the carbohydrate digesting enzymes very significantly. And the same allele fraction also also decreases the blood levels in the STZ-induced or streptozococin-induced diabetic rats. So in future, the isolation and identification of the anti-diabetic moiety from this allele fraction can be carried out. That those drugs can be evaluated for possible anti-diabetic effect. So thank you very much for giving this time.
Thank you, Akbarji.
I would
Can I
also
please
like to thank my supervisor, Professor Sabia Shafi, who is there in the meeting. So, ma'am, thank you very much for your kind supervision during my research work. Thank you. Any question? Anybody can ask. Thank you very much.
just one observation and a question that you have. Am I audible, Dr. Akbar? Hello?
Hello, am I audible to all of you?
Dr. Chan, am I audible?
Yeah, you are very much audible.
Dr. Akbar,
just a minute, sir.
हेलो, चलिए कोई बात नहीं. आई जस्ट वांटेड टू आस्क हिम वेदर ही हैज डन सम
हाँ
इन
सर.
सिलिको स्टडी. इन सिलिको स्टडी किया है क्या आपने कुछ? आपने डायग्राम में दिखाया
I'm
हुआ
not
था.
able to listen, sir. Is anybody able to listen me?
Dr. Chand, can you please message him that we were able to listen all the presentation, but he is not able to hear us. And
Okay.
the next one, Poonam Singh Bhati, can you please join?
Yeah, Poonam Singh Bhati.
Yes, sir. Yes, sir.
Dr. Akbar, please stop to share your screen.
आपको डॉक्टर चांद आपको वहां से ही कराना
Yes,
पड़ेगा वो वैसे कह दीजिए.
yes, sir. Yes, sir. Good evening, sir. Myself, Poonam Singh Bhati, sir. PhD scholar from Janan Vyas University under supervision of Professor A.B. Singh ji. My topic is the application of guar gum 6-amino caproic acid resin from extraction of metal ions from synthesis wastewater using the batch methods.
I think Pankaj sir, are you able to see your
नहीं नहीं हो रहा,
screen?
नहीं हो रहा. चांद सर.
Okay, Poonam
Yes.
Singh, we are not able to see your screen. Please share first.
Yes, sir. Yes, sir. Yes, sir. Video. Yes, sir. Yes, sir. Yes, sir.
आप अपना कैमरा बंद कर दीजिए, नहीं तो वो चलेगा नहीं आपका सिस्टम, फिर नेटवर्क इशू आएगा. कैमरा
जी,
बंद
सर.
कर दीजिए और
जी.
स्क्रीन शेयर कर दीजिए आपकी
जी, सर.
प्रेजेंटेशन.
जी, सर.
Poonam Singh, just share your screen.
Yes, sir. 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 Sir, abstract, sir. Sir, natural guar based resin which containing the 6-amino caproic acid as a functional group has been
आप
synthesized.
अपने काम के पहुंचिए. ये सारा इंट्रोडक्शन वगैरह आप नहीं देख पाएंगे.
Yes, yes, yes,
आप
yes, sir.
काम पे आ जाइए अपने ना, जो आपने प्रेजेंट वर्क किया है.
Yes, sir.
एंड नेचुरल वारगम वाला जो है वो शायद पहले स्मृति ने प्रेजेंट किया था, किसी और ने भी प्रेजेंट, या ईश्वर जी का था वो.
Yes, sir. Yes, sir. Sir, pH titration is the base method. pH titration for the guar gum derivatives. The guar gum derivatives was there to convert into hydrogen ions. The reagents were them the wash in water to remove the excess acid before the being dried at 60-degree temperatures. Overnight, we divided the reagents into the 8 to 9 different flasks, each receiving 0.1 gram. Each flask was given increasing smaller amount of one normality NaCl solutions, then progressively higher amount of Na 0.1 and NaOH solutions in order to keep the solution volume to resin's weight ratio containing deionized water then feed into each flask are required, and once of the pH these tables given below, and the next is graph plot in between the final pH and the volume of the alkali in MS solution. And this at this condition, the lead graph obtained in. Next is the determinants of the distribution coefficient resins and cobalt metal ions. Appropriate volume of the 0.2 m and 0.m sodium acetate were added to a variety of the glass and conical flask for the required pH range of the 8. The appropriate volume of 0.0 mNH4 sodium hydroxide and the 0.2 molarity sodium chlorides were added to each flask. The liquid was filtered after the magnetic stir for the and or the concentration of the filter was determined by double S of the metal ions. Next is the Table's distribution coefficient of the zinc metal ions. In this, we were in this pH range obtains 2, 3, 4, 5, 6 to 7 to 8 in this range. Next is the adsorption of the GS reagents. The maximum adsorption of metals, ion or GCl at the optimum conditions. The Milations, zinc ions 81% approximately, and cobalt 6 ions adsorption of reagents the 70.3%. Result and discussion: the GCA reagents is highly selectively for removal of toxic metal ion from contaminated aqueous solution and the industrial effluent. On the basis, result can be conclude that the KD value of the first increase and then the decrease with increasing the pH here. We will found the KD for the distribution coefficient and the adsorption of the cobalt second metal ions of GCA reagents. Cobalt second ion exhibit maximum adsorption of KD value. On the caproic acid reagents, pH value is the 6, while the zinc second ions does so at pH value. There are the many factors which affect the result are the following. This temperature is the one of the greatest significant element that affect the metal ions adsorptions of resins. As the temperature rise, less metal ions are able to bind the resins to 30 to 80 degrees centigrade temperature. The temperature range used to the GCA resins treatment process, the agitation speed the increase from 0 to 1.5 RPM. More metal ions were retained on the produced sample modified GCA resins. This is due to the fact that the increasing agitation speed promoter metal ions the migration to the surface of the adsorption. Contact times the metal ions adsorption of GCA resins increase as the contact times increase from 45 to 2200 minutes. That it is the ideal GCA resins. The pH is a crucial indicator for the adsorption of a heavy metal from the aqueous solutions. H+ ion and the metal ions find the adsorption site as a low pH levels. The best adsorption occurs at the pH 5 at a gate where as a pH rise, the free metals ions adsorption is the pH dependable metal ion and accumulator on the GCA resins increase when the pH range expanded from the 2 to 8. The sequence demonstrates the rising order of the KD and the adsorption of the ionized metals on caproic acid rise is the cobalt second greater than the zinc second. Thus the zinc metal ion so maximum 81.34% and the cobalt ion the 73.35% on the GCA resins. The ion exchange capacity of the GCA resins found is 5.75 milligrams. Okay. Thus, we can finally conduct that the naturally modified polysaccharide-based resins are more efficient and the compatible for the separation and the recovery of the metal ions from the industrial waste water. Yes, sir. Thank you very much, sir.
Thank you, Ji. Thank you so much. Thank you so much. Finally, you could make it. So,
Yes.
Dr. Chand, we have completed all.
Okay. Thank you, sir.
एक चीज पूछ रहा था मैं ये डॉक्टर अकबर was added लास्ट में बाद में ऐड हुआ है ना, तो उनका कोई नंबर नहीं है इसमें मेरे पास जो लिस्ट में.
Okay, sir. I will provide you the number.
Right. No, I will send you the list. मैं आपको भेज दूंगा तो वो कर लेंगे फिर उसको बाद में. मैंने नाम एंटर कर दिया उनका. ठीक है. थैंक यू वेरी मच एवरीवन. बहुत अच्छा प्रेजेंटेशन दिया है. ठीक है डॉक्टर चांद, shall we wind up?
Okay, sir. Thank you.
Thank you very much.
Okay, am I audible? Hello.
Anji, boliye.
Hanji, sir.
Okay. So, ladies and gentlemen, esteemed chairperson and distinguished speakers, on behalf of the organizing committee of International Conference on Integrative Chemical Science for Health and Environment 2023, I would like to express our heartfelt gratitude for your invaluable contributions during this session. Our session today was expertly guided by our esteemed chairperson, Professor Pankaj Khanna. Their adept handling of this session ensured that the discussion flowed smoothly. So thank you for being with us, sir. I would also like to extend our sincere appreciations to our knowledgeable speakers. Your presentations were not only informative but also thought-provoking. Our gratitude also goes to our engaged audience. Your active participation and thoughtful questions have added depth to our discussions. We would like to thank our dedicated organizing team for their unwavering commitment to making this event as a success. The knowledge shared today will undoubtedly have a positive impact on our field and beyond, inspiring further exploration and collaborations. We extend our best wishes to our chairpersons, speakers, and attendees for continued success in our respective endeavors. So once again, thank you all for your unwavering supports and for being part of this enriching experience. Thank you very much. Thank you very much for being with us. Thank you, sir.
Thank you, Dr. Chan. Thank you very much.
Okay.
Bye.
Okay.